Okay.
Yeah. So in case if somebody is sick, let's suppose to call to the hospital, and we have a corona special sort of care unit, and if somebody feel like having a corona, they're supposed to call to that number, and then ambulance come and bring them and take those patients to our
Okay.
center. That's what we have right now. So actually, we don't have lockdown, and that's what even restaurant and
We are live on YouTube as well, so
Okay.
you may formally start, ma'am.
Okay. So good afternoon, everyone. Welcome to the third day of this international symposium, where we are discussing about the corona pandemic and its implications. So we had 2 days of exciting talk, and a lot of participants who joined from all over India as well as from outside India. So today's session, we have 3 speakers. We have Professor Ashutosh Tiwari from Sweden. Then we'll have Professor Bikash Mehdi from PJMR Chandigarh. And third talk would be coming from USA. So we have Professor Manoj Bhasin. So he would be giving the third expert talk today. In addition, in the panel, we have panelist discussion after the 3 expert talks. So the panelists will have Professor Ashutosh Tiwari, speaker, and Professor Bikash Mehdi, Professor Manoj Bhasin, and we'll also have our Honorable Vice Chancellor, Professor P.K. Khosla, Pro Vice Chancellor, Professor Atul Khosla, and we have our panelist, Dr. Saurabh from our Shule University, Dean Research and Development, Dr. Dinesh Kumar, head of the School Bioengineering and Food Technology, and we'll have Dr. Kamal Dev, Professor in Biotechnology from Shule University. So when we start the panel discussion, we'll have all of them interactive. To begin with, let's start with the first talk. So I'll give a brief introduction to the profile of Professor Ashutosh Tiwari. So Dr. Ashutosh Tiwari is a director at Institute of Advanced Materials, IAAM, Sweden. And he's also Secretary General, International Association of Advanced Materials. This is also located in Sweden. And he has been an expert entrepreneur. So he's a technocrat entrepreneur who actually founded the company called VBRI. So this is called VBRI Group of Institutions located in Delhi. And he's chairman and managing director of this company. And we had an expert talk from this company yesterday from one of his member staff there. This particular group is committed to excellence. So they work with the ideology of committed to excellence. Professor Tiwari leads translational research in biomedical methods and smart devices. So that is his area where his expertise is in medicine and digital healthcare. So he'll be talking about that in detail in his talk. He has been a recipient of many prestigious fellowships, including Marie Curie Fellowship, JSPS, and in NIMS postdoc fellowship from Japan, and so on. And he has published more than 500 expert research articles, edited more than 15 books, 50 books. And he is also a guest editor of many of the journals related to biosensors and bioelectronics. And I think the pioneering technology, which is his credit, is called M Hospitals, which is a virtual healthcare technology. So with these words, now I invite Professor Ashutosh Tiwari to give his talk and share his talk today for the session. Over to you, sir.
no, thank you very much. Just
So others can go mute on video also.
so thank you very much for your invitation. Hopefully, this slide visual. Okay. So thank you very much for the invitation. So today, which I am going to talk more on the programmable nanosystems and devices for cloud care. So cloud care is a sort of a network where a series of different medical services and also the facilities, for example, healthcare experts and also diagnostics and different type of other facilities we can integrate together. So we basically started thinking this idea. I think it was 2013 when we were actually walking where the remote, places how we can bring the healthcare facilities, and that was the idea came in
Dr. Tiwari, your audio is not clear.
Hello, can you get my voice? Is it
Yeah,
okay?
Yeah, no,
So
it's
that was the idea. And in 2014, we created a consortium. It was international consortium. And my role was to coordinate that consortium. And then we created this into the, the translational part. And here I would like to first a little bit explain what is the programmable nanosystems, how we can digitalize. So basically, if you see this this scheme, and here you can see the different type of biological entity can interact and create the interfaces where we can sequentially program and also give them the inputs in the digital form. So development of dynamic nanotechnology, that was the state of art in the AI function. So this is a very, very clear sort of biological functions which we can rely in our daily basis life, even in the body. There's millions of the reactions and entity we can see where the functions are very, very smooth and without any interfaces, all running sequentially. So that's elements we can create for the future biomedical, and that's what we can bring them if on the mobile platforms and bring them to the home care devices. So dynamic nanosystems prevent to create smart interfaces, and that's what we can engineer into the digital healthcare networks. So if you see the background of the healthcare, so there is a three pillars we can say that like a treatments where we think about the therapy and medicine and diagnostics, and the whole idea came in the philosophy like where the magic bullets concept, but the four components still we have to address like real-time diagnosis, targeted therapy and monitoring the cause and the response of the action. So all these four components need to be addressed if you want to have smart healthcare platforms. And this is also important to know the challenges in the healthcare. So I would like to give the 5 different areas which is very important to know. For example, the diabetes, it is a very important because 2% of the world population get affected because of the carbohydrates and the lifestyles. Cardiac diseases and strokes, it is a very important area where almost 17 million people die globally, and by 2030 it might be raised like 25 million people. So this is a very important area. Infectious diseases, which we are actually facing the pandemic situation, it is very, very important, where 16.2% worldwide deaths every year we have, and every 1 or 2 years or maybe we can see several different diseases and infections we are facing. Right now, the major challenge is COVID-19, and where the SARS-2 and the SARS-1, it was before there was some epidemic situation as well. So basically, this is also a very important area where need to be have proper healthcare. Cancer is another field where almost 10.9 million people die, and about 40% of the diagnosed patient belongs to the Asia. So very important the side, like where we have to have sort of intensive care, and by 2030 might be 13 million people maybe die per year. Aging population is another area where like 2 billion people probably expecting by 2050. So today, since our major focus on the COVID-19, so there is some key points we need to know, like this virus is affecting respiratory tract. We all know a lot of different type of a lot of the common cold and pneumonic symptoms, fever. Usually lives, it's mostly, this virus probably have more genetical close to the bat virus, and it's more originated from the wild animals. So basically, it is a sort of animal virus which we are, try to understand why it is transmitted to human directly or other animals. So we can also transmit, this virus can transmit from animal to human, and also, via the respiratory droplets. So that's what we learn. And the challenges are the current pandemic situation is declared it's a health emergency worldwide. Social, a lot of effects we are facing, especially socio-economic effects, and this diagnosis, control, and the coronavirus. Now it's uncontrolled and it came in the pandemic situation. So that's what we are basically facing. So we need to have mass screening, and that might be the immunological or genetic methods. So objective is like a current worldwide health emergency, which we basically want to smartly tackle this situation. So we need a smart strategy where wireless technology could help. And our research on the prognosis of such chronic infection, especially the wireless medicine, is really, could be the helpful, and adaptation of the advanced technology with the logical integration is important, and could be the basis for, could be the smart strategies. The most important thing which we learn, like prognosis and prevention. So we rely on this is a cheaper and fast immunological methods at the first stage. Diagnosis at the molecular methods. This is also, it's very popular, but it is time taking. Molecular methods consist of the, sort of the confirmatory methods, and treatments also, like some sort of antiviral or anti-pathogenic drugs right now using, but still it is an unknown area. So a lot of parallel research and developments going on. So preventive and prognosis of this coronavirus pandemic is only the one way to to stop the mobility, and also contacts to control the management. So this is the practice which we are adopting right now. And if you see the coronavirus, so it is like a corona-like protein structures at the periphery, and inside there is a RNA sequence, which is basically genetic material. So these two areas which we are trying to understand, and then this could be the sort of way where this spike protein supposed to first identify, and then inside RNA there is a sequences which need to be understand, but there is a several mutations. Mostly every week we can see mutations in this coronavirus. Immunological assay, where the ELISA and antibody strip test are also very popular nowadays, but there is several limitations, especially the detect like antibodies, and of course the time is another like a 4 to 8 weeks need to be exposure to the virus, and then we can have this to detect. So that's one thing. And second area where like we can see the like IgG test or IgM test line. So this is also very helpful, and I think in India several research groups, they have prepared this kind of testing kits. Genetic assay, where the real-time PCR test, where it is very the common and most authentic methods, where the sample collection from the nasopharyngeal and then detect the virus with the RT-PCR or PCR testing, real-time PCR testings. Different type of even receptor we can see, like ACE2 or AC receptors. ACE2 is also now using several test kits where the coronavirus, the protein, the spike protein, and by these methods we can also detect the virus infection. AC2 receptor in a human organ, where you can see the several organs get affected, and that's what the patients die because of, not because of the virus, because of the organ failures. So that's what the major impact, like especially the patient, how the patient survive, especially start from the the respiratory tracts and then lungs, and after that this virus also affect the different part of bodies and organs. So the principal objectives, especially what we need here, we need to have individual strategy for the disease management, where the personalized healthcare, finest therapy, and smart diagnosis. All these components need to be addressed, and the diagnosis at the beginning or at the molecular level is important. So therapy at the molecular level, and that's what we need in the healthcare sectors. So if you see the new age technology, where you can see there are several wireless sensors and different type of electronic casket. You can see here the wireless bacteria sensor or concept of different light or neurological, the sensors. And the same time, we can see also the smart, for example, phone coupled with the different type of application, e-tattoos or non-invasive methods, where the wireless and the smart watches and smart goggles. So different type of methods now available, and all these are somehow integrated with the different type of methods, where the non-invasive or invasive technology. I'm going to present some sort of different biochemical application, where the dynamic biological interfaces in coupled with the stimuli, or even the different factors like pH, enzyme, or ionic strengths, where we can couple with, and you can see we can control where on and off electronic mobility on the surface. Even cell adhesion we can also control by using different type of stimuli. Antibacterial surface or antiviral surface we can create by different type of methods, on-demand sensing. So all different techniques actually somehow we can apply, and that's what I'm going to present some examples, where switchable zipper-like nanosystems, where the bioelectronic interface using a graphene, and here you can see on and off type of phenomena, where the receptor and donor interaction simply tuned by temperature. That's what, like a 20 to 30 degrees. So very small temperature range can, the switch the electronic mobility like where the enzymatic reactions, could control. And that's what the flexible and smart bioelectronics phenomena we can see here, on and off states with the minor change in the temperature. And that's the temperature significantly give the way where the on and off switchable bioelectrocatalysis could possible. Then another example you can see here, the light trigger like wireless technology, where the light with a certain wavelength. Here you can see like UV and visible light, and control the enzymatic reaction, where you can see here enzyme could, react with the analyte even on the nano surfaces, and that's what you can control by the remote control, like where without touching the surface. And here the similar phenomena like on and off stages with the light. And that's another area where we were looking into the auto switchable bioelectronic system, where we can program the different type of functions within the system, and the stimuli or the particular functions get into, we can see the auto switchable surfaces and auto switchable dipper-like surfaces and electronics, where the on demand or on and off phenomena we can see by the auto programming. So that's what you can rely. And another area which I personally started working in after 2010, where we try to start the programming the bioelectronic phenomena on the nano surfaces. And you can see here light and temperature, because these two factors you can easily integrate, and by these methods you can track and you can also program the different substrates and different biomolecules in the system. And here one example like AND gate phenomena, where we have seen in the three different methods, electrochemical methods, and 1 1 1 or 1 0 or 0 1 or 0 0, different type of combination we can try, and we have seen that it was pretty much rely with the same way, even though having a different methods of analysis. OR gate phenomena we have also done with the similar way, and we have also seen exactly the similar responses with these three different electrochemical methods. So this idea came into our mind, and then we started thinking how we could digitalize the healthcare. That was probably you have seen hello. So that's what we can see here, like where the medical sensor can integrate with the mobile devices, and that's what, and we can send these different results into the server. So health servers or cloud servers, where even though patients are sleeping or walking or whatever, the different. So all these medical sensors can integrate non-invasively on the body, and then integrate with the mobile phones. So that's what, and this is a very new area where you can see like a new first telecare. It was approved, FDI approved in 2012. So, and it was actually the glucose sensor, glucometer, wireless capable glucometer with the Bluetooth without cable. So these areas where given the sort of different sensors and practices. So you can see here that several lifestyle products we can have right now in the phone, and coupled with the especially the physical activities, certain even yoga sensor or safety sensors we can have integrated with the mobile phones. That's what the idea we actually integrated with our platforms, Yum Hospital, where you can see the different type of sensors, especially using AI, machine learning, or even IoT, integrate with the smart, even control or a belt or maybe watches. So different type integration, even a smart finger. So all these different inputs we can put into the cloud medicine, and we can have the results. So the next generation of the healthcare management system is important, where the artificial intelligence going to be a much more close and diagnosis, probably maybe millions or even close to the because doctors sometimes also feel such type of assistant, and that's what AI medical systems can give us the close diagnosis, and we can save the lives. We are also working with the cloud care for COVID, and it is like virtual kit where we can assess the disease hotspots and tracking. We actually completed the 6th stage of field trial where the total cardiac care we have given the solution, even it was highlighted in the European magazine. And we have all sets of, so we created like a virtual hospital, and we can connect the patients and different type of facilities through the mobile devices. So the conclusion is like a digital healthcare nano devices, of course, comes very high attention in commercial as well as academic arena, and we can use this kind of technology, to create the facility at home, and the cloud medicine certainly give this kind of awaited facility. Nanoelectronics certainly is going to be create interfaces for cloud healthcare, next generation of healthcare. Nano system is triggered and integrated with the E and M platform, such as digital health, cloud care at home, especially non-touch, like without touching, the patients, and having a sort of a distance healthcare infrastructure. So tunable functions ability imply the parameters that could be extract the information, maybe physical or biochemical, and logical supplement, of course, microelectronics, wireless communication, software modules, all these sort of give a integration, and all together we can get wireless medicine. So that's this project. As I said, it was started long back. We had collaboration with more than 50 organizations, almost 15 countries. You can see this map, world map, and I think I have been visited actually, where we actually invited most of the researchers. So you can see a very high in then hard work of the researchers to get this product and translate this technology for the society. So thank you very much. So now, right.
Yeah. Okay. Thank you, Dr. Tiwari, for your wonderful talk. So this is the new technology which is going to come in even medicine, right? So that we will be going for AI for everything, having least of human intervention. So again, we would also like to have more questions from you. So I think we have the next speaker also join. During the panelist discussion, we'll take all the questions from the audience as well as from the panel speakers for you. So thank you again, sir, for the talk, and please stay tuned for the panelist discussions. You can mute yourself and stay at the background. That's all. Either way is fine. So thank you, sir. So now we'll move on to the second talk from Dr. Bikash Medi. So I request Dr. Bikash Medi to turn his video on. And your audio also, sir?
Yeah, I've done it.
Okay.
Can I put the slide? Slide screen.
Session. Sir, your presentation is ready?
Yeah.
Okay. So I'll briefly introduce you, and then you can start your presentation. So we have the second talk for today, which is from Professor Bikash Medi. So Dr. Bikash Medi is professor and additional medical superintendent in PGI-MER, Department of Pharmacology in Chandigarh. And he is also the coordinator for the Pharmacovigilance Center of PGI-MER. His area of expertise is experimental pharmacology, clinical research, nanoformulations, pharmacogenetics, and stem cells, and so on. He has more than 200 publications to his credit. He has applied for patents, 2 patents. He has completed 30 extramural projects, and he has guided more than 110 students for DM and other degrees. And he has more than 20 years of experience in teaching and research, and with more than 50 prestigious national and international awards coming from ICMR, IPS, and so on. So with this background, now I invite Professor Bikash Medi to give his talk on drug development and pharmacotherapy for COVID-19. Please, sir, you can start your talk, Dr. Medi.
Is slide is displayed? Everything is okay?
Yes, sir, your screen is okay. Your audio is a bit low. If you can increase the volume.
So I can stop the video because of audio quality will be good. That is fine with you?
Okay, no.
Yeah. So good afternoon, everybody. What I'm going to talk about is drug development and the pharmacotherapy today. As you know that a lot of speakers had already had elaborated on situation of pandemic situation in India and across the globe, and I need not have to go detail. So what I'm going to do is,
Video नहीं start किया.
is there any problem? Can you hear me now?
Sir, please continue, sir.
Yeah. So I'm just going to talk about the drug development, which is important for how to develop the drug target against COVID-19. So when the first case was reported, then we started working on this. And initially, what we did is, what are the different targets? So if you look at that coronavirus, it is a single standard RNA genome. So in this, we try to look at that different target, which you can think of, S1, S2 domain, then proteases and terminal. And we wanted to find out that whatever the existing drug is there, whether it can be bind or it can inhibit the viral replication or not. Now, typically, if you see that it is a presentation with common cold, pneumonia, bronchiolitis, rhinitis, typically what we get in viral infection, upper respiratory tract infection. Now, knowledge about COVID-19, it's a dynamic process. Though 2 months back, we must be thinking that it is only upper respiratory tract or lung infection, but later on now we came to know that this is also, affecting the thromboembolic phenomenon. So people have tried that can you give some other drug, like people have tried with heparin also. There are so many. There are more than 108 drugs have been tried in different clinical trials. That is, if you look at the clinical trial registry, either in India or clinicaltrial.gov.com, you can see that there are 1,200 plus trials going on, including stem cell therapy, including other anti-protozoal drugs. There are so many drugs. We have already heard about ivermectin. Now, just look at the structure of the coronavirus. So it is, you can think of that spike S1, then the protein structure, then membrane protein, what we talked about, S1, S2, then N-terminal and proteases. Now, we have to think that how many of the existing drug we can think of that if we use this drug, it is acting through different pathway and it inhibit the, viral replication. That is what we talk about the repositioning of the drug, because it is not going to take long time. Already safety and efficacy is already there, so that we can think about that, can you with a particular dose, it can be repositioning. So some of the important point I'll discuss when you think about the repositioning. So this is what we talked about in a spike protein, then membrane protein, then E protein and other N-terminal, and whether all these structure, when you give the drug, it is acting through, whether it has a dual effect, or ultimately question is that whether it can inhibit the viral replication or shedding the virus, it's going to help or not. Now, that is why the very important point is we need to understand the molecular basis of transmission, because if you see, since the beginning of this infection, people are asking, is it infected from human to human, or is from human to animal or animal to human? There are a lot of questions. Now, what are the target organ? Is it only lung? So initially we have information that when there is a sneezing, when there is coughing, it is going to have a droplet infection. But later on, we came to know that viral is also being excreted through the stool. Then one has to be very careful, even if you go for a quarantine. So all these, because of this fecal oral, that it is excreted through the stool, so we have to be very careful. So these are some of the new information has come. Now, there are a lot of clinical questions it is asked regarding COVID-19 because it is correlating with ACE2 receptor expression. Now, if you see clinical condition that suppose now we give hydrochloroquine for treatment. Now, because of this ACE2 inhibitor, whether you can use concomitantly any S2 inhibitor like antihypertensive, or you talk about some of this, NSAID, ibuprofen. These are concomitant medicine, whether you can use, and even if you use that, whether it is going to deteriorate or not, or it can be used. So that is what the receptor expression of S inhibitor is very, very important in terms of that COVID-19 drug development process. So now if you see, there are a lot of antiviral drug has been used. One of the antiviral drug has been promoted earlier, like you can see that ritonavir, lopinavir. I'll talk about in detail all these anti-HIV drug because it has been found even in docking also that it has a potential effect of this drug. Now, how many of the drug is the spike protein? So all these, if you see that when you go for a in silico study, you can scan that how many of this compound, it is a high affinity in terms of kinetically or dynamically, and it will be effective. So that is what spike protein people have tried. Then the membrane protein people have tried. Then E protein and N-terminal and proteases. So I'll not go in detail in the molecular structure. So these are the target we have to be really found that when you say in drug development, whether it is acting through this particular target or not. So that is what we have to look for. All these, target. So there are numerous new targets have been come. I think you should look at that. Some of the paper have been published in Indian Journal of Pharmacology, and the next edition also it is coming. So one of the important is hemagglutinin esterase, whether it is acting through or not, it has a significant effect if you look at the data of this particular enzyme. So these are, we need to look at when you look at, efficacy or safety of the drug, or in terms of efficacy, how much it inhibits with the viruses or COVID-19, we need to look at RNA-dependent polymerase. One of the remdesivir has been promoted. Then some of the supplementary like vitamin C or antiviral, like there are series of antiviral have been used, like start with lopinavir. These are even an anti-malarial drug like artemisinin, chloroquine, hydroxychloroquine, or Arbidol. So many drugs have been used, including interferon alpha or beta has been used. Now, question here is, there are a lot of application and a lot of people claim that this drug is going to affect or it will work. Now, if you look at the drug research and development, suppose if you do a in silico study and you find a particular drug is a very high affinity in terms of inhibiting through a particular target site. So you have to really think that what is the data from in silico study and how much it is beneficial and what are the ADR effect profile. So anybody says that this particular drug is like, if you think of that hydroxychloroquine, why it has been preferred, you can just think of, because if you look at comparatively with the chloroquine and other drug also, you have to really think that how much it is concentrating in lung tissue, whether it is has any interaction with S inhibitor or S receptor. So in general, many drug, it might show the benefit or innovative technology, but you have to think that a target organ, whether it is concentrating on the lung or it is inhibiting, how much it is inhibiting, what dose it is actually inhibiting, is it feasible dose? These are the points need to be looked at. So when you look at the evidences for repurposing purpose, when there is a lot of claim, so we have an in silico, but after in silico, you have to really go for an in vitro or in vivo. There are several animal model studies. So COVID-19, you can do it in mice or you can do it in rat and other model. And before you go to the animal, we have a lot of cell line where you can show that its efficacy, that how much it is efficacious. Of course, it is limitation is that these antiviral, when you do in vitro study or in animal studies, you need to have a BSL-3 or BSL-4 facility, especially BSL-3. So look at that in vitro study and in vivo study, how much it is showing its efficacy and its safety. Then you can look at the dose, what dose it is inhibiting the virus and how much it is inhibited and what is the dose of safety limit. So look at that evidence, then you can show that this particular drug, it is inhibiting. Like if somebody is claiming a particular herbal compound also that it might have an effect on COVID-19. So you have to really think that, do you have a existing information that it is act as an antiviral or similar antiviral? You can ask that, did it find some efficacy in SARS or Ebola, because similar kind of virus. So then you look at the in silico data or in vitro data, then you screen that how much. Basic purpose is that since pathophysiology is changed, so you have to really think that when any molecule you think of promoting, then you have to think that, is it acting as an immunomodulator? Like you can take a case report that one of the lady was dying. So one of the doctors, he came to know that from the Italian published literature, that one autopsy report shows that there is also affecting the thromboembolic phenomenon. So that doctors there, he started with anti-stroke drug and TPA it was used, and the patient was miraculously survived. So all the drug when you use, I'll talk about in detail the clinical case, that immunomodulator properties that also need to be looked at. Other property when you think of repurposing is, you look at the toxicity profile, because it is for the short duration. Of course, you have to say that what is a good toxicity profile, and also pharmacokinetic profile, that what dose have maximum concentration in the lung tissue and volume of distribution, route of admission. These are adverse reaction profile. These are important point you need to look at. Of course, if you have a new compound, you're going for a patent, or you can go for an off patent. So prerequisite of the repurpose, there are a lot of effect. Like you look at the in silico data, in vitro data, in vivo data, and already existing drug, what dose, that is it the existing dose it is going to act, or there is a new dose, low dose, that you have to look at the quality of scientific evidence. And also when you know that if it is off label, now because of pandemic situation, you can immediately go to the regulatory authority and get an approval for particular drug for the COVID-19. So if I conclude the drug discovery, that main purpose that you need to know that what target you are working. Is this drug is acting to a different target? What is subsequent molecular injection in order to inhibit the viral application? Now coming to pharmacotherapy of existing, as I say, it is a dynamic process. Every day we're learning. You are getting a new information. Based on that, our recommendation of the scientific committee for management of COVID-19 is always been a dynamic process. But otherwise, if you see typically a COVID-19 patient, how they present, it is a typical viral infection. We have a lot of cases of dengue fever and H1N1, swine flu. So typically, if you see that symptom is the fever, patient complain of cough, and also there is, they cannot hold a breath. There is a shortness of breath. So if there is a problem, then definitely it has to refer. If there is a high fever, cough, and sneezing, so individual has to go, or there is a history of international travel or any kind of travel from this particular zone. So it is symptomatically, that earlier it was recommended all the cases will go for, testing. Testing is, it is RT-PCR, where there is a sensitivity is that you can confirm that whether it is COVID positive and COVID negative. So when it is found with COVID positive also, we have to really categorize that whether it is a mild case, or it is a moderate, or it is a severe. Now, if you see that in case of moderate to severe cases, what you look at the respiratory rate. Normally we breathe, 70 to 18, but if it is go beyond 24 per minute, so definitely, and also you look at the oxygen saturation by pulse oximeters. So if it is less than 94, then definitely you require that it need to be admitted. So the treatment option is depend on, in case of a mild, you just quarantine, but otherwise now, moderate to severe, you start with prophylactic. If there is a history, you start with hydroxychloroquine as per the recommendation from Indian Council of Medical Research, that you give hydroxychloroquine 400 milligram on a first day, twice daily, then weekly till 7 weeks. Okay, so this is what the based on the kinetic profile, because hydroxychloroquine has a very long half, like 54 days. Now the question here is why you prefer to use hydroxychloroquine compared to chloroquine. So you can go for existing data, because if you look at the hydroxychloroquine, that maximum dose you can use up to 1200 milligrams. And we have a lot of information or evidences that hydroxychloroquine used for some other reason, like in a rheumatoid arthritis or condition like SLE, where people are consecutively taking for years together. So otherwise, that if you see that how hydroxychloroquine act as antiviral, and think of dependent. Now, when you compare to the chloroquine, it is dose-dependent antiviral actions. So if you go beyond 750 milligram, it acts as an antiviral. So here the question here, if you get it even a PKPD data of the experimental data, if you see that compared to hydroxychloroquine and chloroquine, so when it was done, it was found that on 5th day, the maximum concentration with hydroxychloroquine is remain in the lung tissue compared to chloroquine. So this is one of this, evidence has been used that it is preferred to use hydroxychloroquine because it has more penetration into the lung tissue. So there are so many data. People say there are a lot of queries that hydroxychloroquine it has cardiac arrhythmia, but in the both sides, you can think of this data also, that data with safety and efficacy. But major concern with hydroxychloroquine, you have to be careful that in case of a diabetic patient or in case of an existing patient with a problem with cardiac. So it is recommended that before you start hydroxychloroquine, it is with the prescription only, and also that baseline ECG should be done, and there should be active monitoring of these people who are taking, healthcare professional taking, hydroxychloroquine, or there is a close contact where they are taking hydroxychloroquine. Now it has been also been said that all the security person, frontline, workers, they should be also be provided with hydroxychloroquine. So when you get a, moderate to severe patient, you have the treatment is oxygen supplementation, start with antibiotic, antitussive, or antibiotic. But here it is
Dr.
very,
Mehdi,
yeah.
excuse me. Your slide is not moving ahead.
Yeah, I'll do that. Yeah.
I think it's all stuck on pharmacotherapy, that slide.
So I'll just complete that. What is the overall management? Then I'll go to the individual drug.
Okay.
So you have hydroxychloroquine, but here it is very important that there are so many trials, they recommend that it is given with azithromycin. So this is also because if you look at the recommendation of azithromycin on a macrolide, in case of elderly, there is a problem with QT prolongation. So one has to be very, very careful when you give this drug that it has to be active monitoring. Otherwise, management is depend on whether it is mild, you have a supportive therapy, whether it is moderate or severe, you have a other treatment according to the need and severity of the disease. I'll not talk about detail that how the virus spread from the China to the other places. So everybody knows every day we check wall meters and how much it has been, expanded or number of cases with mortality and other thing. So typically, if you see that in COVID-19, there is an uncomplicated, it is also unpredictable, especially if you see a younger population, they have not having a full symptoms, because even it is positive, majority of the patient is asymptomatic. Majority of patient is asymptomatic. So that is why it is important to keep all the PPE, personal protective equipment, because you do not know that how many are suffering from this, because these people are asymptomatic. Otherwise, we have a mild pneumonia or severe pneumonia or acute respiratory, that is we call it SARI, severe acute respiratory distress, and sepsis. And that is what the mortality, if you see that those people already suffering from underlying disease like diabetes, severe hypertension, other underlying disease, they have a more severity compared to the younger or elderly population, compared to the elderly population. Now here, general principle which is there that that COVID-19 patients are suffering from acute respiratory infection, and also that one has to be that all these generalized like that how to prevent, or in case of a cough or in case of a sneezing, that we have already understood. But here it is also important that you have to be take care also. We do not know that how many of the people, maybe there is a transmission from human to animal or animal to human. So one has to be there. So you can refer it to some of these papers which have been already published. Now, how to manage this? This one is infection prevention control, that you are really trained. In case of hand hygiene, use of PPE, what kind of PPE it is there. Okay, you can read about devices. Like you say N95 marks. What does it mean? That means 95% can be prevented. So you have a 1 layer, 2 layers, 3 layer, depending on the cases. But I want to make you one point is, even a common man, we do not need a 95 and 95 marks, because it is required for those who are frontline workers. They are working for COVID-19. So these are the point need to be used, that this should not be misused because of limitation of particular quality PPE. So and cleaning environment, there are a lot of issues that if you buy a vegetables, keep in freeze, that how much the COVID-19, how long it can remain. People say that it can be remain for hours, even steel surfaces. Then how much it's related to the temperature. So this all general question you can just read, and you need to understand that how it can be prevented by using some of the other alcoholic based therapy. So early supportive therapy and monitoring, as I said, that depending on severity. So when you get moderate to severe cases, you look at the respiratory rate, and also you look at that, how much it is saturation of oxygen. So this is important. Depending on that, only you recommend it. Suppose oxygen is less than 94%, definitely will recommend. So then empiric use of antimicrobial, because maybe that other associated infection. So that is why that it was used, azithromycin or other antimicrobial are used. But one has to be very careful about looking at active monitoring is required. Of course, other measure that you go for, imaging technique, and especially if you see pathogenesis today, like earlier it was only think of a pneumonia, then later it was some thromboembolic phenomena. But those people who died because of mortality, it is because of cytokine storm. Because of excessive amount of cytokine has been released. If you look at that clinicaltrial.com, that how many are monoclonal antibody people have tried, there are several studies are going on in order to, can you reduce the cytokine? That is why if you look at a severe acute respiratory distress syndrome, that question here is, do you like to use corticosteroid? Or you can use methylprednisolone. Some of the cases, if you see that because of cytokine storm, people have used methylprednisolone. One of the hospital in the US, where there's a briefing has been done by some of the experienced doctor from Wuhan, they said that they initially start with methylprednisolone. And it was found that when you start a monoclonal antibody, the reduction of cytokine, it takes a long time. But if you use methylprednisolone, it's a drastically it reduced. So over a period of time, when you pool the cases and you find that which one is more beneficial, you'll get to know that. But till now, a lot of people, they have used methylprednisolone, and it has been found that all the cytokine storm, that cytokine level drastically come down. So that is what you have to see. In case of a pregnant woman or pregnancy, so all these other factor also be considered. But in case of a cytokine storm, this is what it is relating to the more cases of mortality. If you see that they develop cytokine storm and they die. Now, question here, as I said, there are more than 108 drugs has been used. Now, if you think of, you make a list of the drug which is antiviral, then you can see that how many antivirals are used. Start with lopinavir, ritonavir. There are so many antivirals they have started, and so many studies have been done. Some have marginally benefit, like you say that days in hospital stay or days required to cure the temperature or control the temperature. There are so many objectives it was putting. But here, one thing you need to that in case of a severe cases, you need oxygen or mechanical ventilation with other drug therapy. Now, question here is basic drugs like use of chloroquine and hydroxychloroquine. I have already elaborated that why hydroxychloroquine, especially for prophylactic, it has been used, and it has been shown that some of the studies is reported that when you use hydroxychloroquine, how many you can put the question that after use of hydroxychloroquine of healthcare professional, how many are developing positive or you can correlate with mortality. It has been shown that some of the study, though it is not been published, that hydroxychloroquine it is minimized or severity is minimized. So that over you complete all the studies, you'll get to know that what is a real efficacy. But still, we have also published meta-analysis where it shows that it has the benefit when you use the hydroxychloroquine. So these are the recommendations in earlier when it was started that 400 milligram it is used hydroxychloroquine, that is on first day, twice daily. for healthcare professional, and it should be continued till 7 weeks. As I told you that it has a long half-life, 54 days, so it can be beneficial. But when you concomitantly use azithromycin, one has to be very careful at looking at a cardiac arrhythmia. Another point, important point with hydroxychloroquine, it should not be prescribed in case of a children more less than 15 years. So that, but whenever you issue a hydroxychloroquine, somebody use it, baseline ECG is required. There's a monitoring mechanism is there. They can monitor, and we have a PVPI system, Pharmacovigilance Program of India, where there is a toll-free numbers. We can also report any of the problem, and we can have a national database for this. We have already been doing this over a period of time. So over a period of time, there is a new recommendation also about continuing the hydroxychloroquine that you can refer it to advisory of the new. Coming here, combination lopinavir or ritonavir, or you think of other antiviral drug. Okay, so there are so many studies have been done, and it has been found it is benefit is there. But when you do a meta-analysis or combine all these, that how much it is beneficial is only time will tell you that how much it is beneficial compared to the standard therapy. So if you say COVID-19, that because all this antiviral has a lot of adverse effect also in terms of hepatotoxicity or GI problem, other associated problem that also look into this. One of the drug has been found to be promising is ribavirin. So this has also been used in many of the trial, and it has been found that in systematic review, that clinical experience says that ribavirin in the treatment of especially severe acute respiratory syndrome has been found to be effective. So result is inconclusive because of also we have to compare with the toxicity profile. So this is also one promising drug with ribavirin with interferon, beta interferon has been used in many trials. So you can think about the number of trial once it's complete, because all the trials are still going on. So we do not have a conclusive, report. Once it's completed, you can pull the data, you can see. Now, other antiviral, if you see that, if you look at how many of the studies is coming from China with other antiviral, one is drug we use is H1N1 infection. So this is also shown that promising effect that even alcohol is more promising. There are a lot of anti-protozoal drug, nitazoxanide has been used. There are 28 clinical trials going on. So there are many drugs people are trying in, like favipiravir. Basically, it inhibits the RNA polymerase. But also try in COVID-19 patient. Now, in a recent time, one of the antiviral has been projected is remdesivir, and it has been found that it has a promising effect in COVID-19. Now, people are trying to get this medicine in all subcontinent, but here you could see that though it is very shown to be efficacious, but cost factor you could see that how much can we afford this medicine, because it is very, very costly drug, but it has been shown to be promising in remdesivir. So current all the drug, if you see that under the clinical trial, but over a period of time, if you see that those who are completed within a number of studies, how the design has been done, how many are open trial, everything, the biases we have to be evaluated and pull the data and see how much it is efficacious is there. I already talked about corticosteroid and methylprednisolone and compared to in all these monoclonal antibody or biologics has been used. So you can look at the data. Now, question coming in the last is, there are many studies are dying with like plasma therapy. If you go back in 100 years and see that other 100 years back also, any of the infectious disease, we have tried this method. Those who are infected and they get cured, and we take the plasma because there is an antibody. So what we do it is, here also there are a number of studies, number of centers, it's more than 50 centers, there plasma therapy is going on. So the only challenge will come, I didn't talk about a vaccine, there are 70 vaccines are in a trial. So if you look at this, what are the challenges? If you ask the question that why you do not have a vaccine for dengue, why you do not have after so many decades also vaccine for HIV. Now here in COVID-19 also, if you talk about vaccine, that you have a cases of reinfection. There are 92 cases from South Korea. There are a number of cases from China, that those who are already suffered, they got cured and they are reinfected. You can also think of a data that how many are in from hospital is discharged, how many had went to the house and they died. So these are some real challenge it might comes into the vaccine development. Of course, there are some of the studies shows that the promising one over a period of maybe by October or next year we'll have a vaccine and it can be protected. But all this limitation also we need to be discussed that in case of a plasma therapy or in case of developing vaccine, you need to also really look at that how many challenges are there. But still now the plasma therapy is promising, vaccine is under development. There are a lot of, trial is going on more than 70. So that is what we have used. That what is a conventional drug we have? One is we have hydroxychloroquine or anti-malarial drug. We have all antiviral drugs, including anti-interferon beta, which has been found to be promising. All the biosimilar, you can think that several biosimilar has been used because the mortality is high is because of cytokine storm. So this is what that number of cases you can collect the case series, you can analyze the data that how many of them actually survive, which one out of that is more beneficial. You can think of and you can have a convincing evidences that how we are going to manage, because as I say, it is a dynamic process and every day we are getting a new information. So you have a large trial and shows that benefit, definitely it will be implemented. So I think it is quite challenging of the drug therapy or in drug development. What we are trying to do is we are trying that can you reposition any of the medicine. I didn't talk about herbal, like you can see that some of this publication of Chinese herbs which have been found to be beneficial. Similarly for Indian herb also, that herbal medicine, that, but question here is when you think that this thing is antiviral, you have to really think that can you give stand alone? Second thing is, do we need to, like we look at that, is it affecting on particular SARS or Ebola or now it's COVID-19? Now, if you find to be benefit, should we go for a add-on therapy? Do they have a synergistic effect? Do they have an additive effect? So these are some of the research questions before you start the therapy or do the research. You need to really look at the theoretical aspect. Then you can implement. I think what I'm trying to make it is that we can do much better. We have existing information, we can repurpose the drug, but still we have to see that looking at the evidence and because of dynamic information that every day new that we have to compile and think of a conclusive one. Of course, we have to really look at the vaccine. If it is there, definitely we can get rid of this pandemic. Thank you very much.
Thank you, Dr. Mehdi. You can have your video on.
Yeah, I'll just try. I'm not able to do it. Oh, yeah, I can do it. Yes.
Okay.
Yeah, can you see me? Yeah, thank you.
Yeah, thank you, sir. Pradeep, can you unmute my video? I can't do it. Thank you, sir, for the wonderful talk. This is directly coming from the patient level. So you have given the details on what is actually going on the treatment level. So again, there are a lot of questions which have come up in the question answer box and the chat box. We will take it towards the end after the panel discussion. So I would request you to stay on. You can stay on the mute mode, audio video, and join for the panel discussion.
Thank you.
So now we have the next talk. So thank you, Dr. Mehdi. So we'll move on to the next talk. So we have the third expert lecture. So I would request Dr. Manoj. Yeah, you're already on, sir. Good afternoon, sir, and welcome to this session. So we didn't meet you before. So I think it's early morning in United States.
Yeah, it's pretty early morning.
So we made you wake up early today. So welcome to this third day of the International Symposium. Thank you for joining, and Shulini University thanks you to give your valuable time to us so that you can expose us on the COVID-19 aspects from the United States. So we had Indian representation. Before this, we had a Sweden talk. So we have got now the third continent coming. So you're going to give the American continent's aspect. So briefly, I will introduce you, sir. So we have the third lecture by Professor Manoj K. Basan. So he's Associate Professor of Pediatrics and Biomedical Informatics in Emory School of Medicine in Atlanta, Georgia, in United States. He is also an associate member of Benson Henry Institute for Mind Body Medicine in Massachusetts General Hospital, Boston, MA. He is also an associate professor of biomedical engineering and bioinformatics programs in Georgia Institute of Technology in Atlanta, Georgia. In addition, he holds a position of scientific director, bioinformatics and systems biology shared resource in Winship Cancer Institute, director genomics, proteomics, bioinformatics and systems biology at Children Healthcare of Atlanta, and director single cell biology program at EFLAC Center and Blood Disorders Center, Atlanta. So I think so you come up with a huge profile on bioinformatics and system biology. So it would be very nice for us to have your thoughts, and his talk is titled Epidemiology, Diagnostics and Therapeutic Approaches to Combat COVID-19. Over to you, sir, Dr. Basan.
Yeah, thank you very much, Dr. Anuradha. I really appreciate you inviting me over. And I would also like to thank my dear friend Saurabh, who sent me an email that, okay, I should give a talk. So I really thank both of you, as well as other faculty of Saloni University. So as Dr. Mehdi said, basically, I think COVID-19 is like still going strong, and it's unable to, I think, find anything substantial vaccine or drug that can control it. So I will spend next 30 minutes like what we are doing, what others are doing, and what is the perspective coming out from all around the world, like how to really tackle this dreadful disease. So before I go into that, I will go to like my lab's profile. So my lab is not infectious disease lab. We do a lot of drug repurposing. We do a lot of single cell omics. We do a lot of alternative therapies. Like my lab has established the genomic profile for yoga and meditation. We do a lot of cancer vaccines and biomarker discovery. And a small part of my lab works in understanding the genome landscape of infectious diseases. We have a previous record that using the genomic tools, we are able to figure out like how the staph infection that alters the host genome, and how can we use that information to repurpose the drugs and find the new therapies for resistant staph infection. We did the same approach for Zika, where like we use the genomic profile to understand like how does Zika really change the genomic profile of the cells, and identified the therapies for that. And so that is done around 3 or 4 years back. And as Dr. Mehdi was saying, basically, so last 3-4 years, we are working on optimizing the drugs, like how to deliver them, how to really improve their therapeutic efficacy. So I think in Zika case, we are trying to get a repurposed drug that can work like immediately. So my group is doing some work in that area, whereas like a lot of other groups around the world are doing work into that area. So I focused my research totally on genome viewpoint, and like evolution of genomic happened with the discovery of DNA, and then we sequenced the whole genome of human being in 2001, and now we are in a position that we can sequence every cell of a like a diseased tissue or a infected tissue, so that we can really understand at a granular level, like how does that happening. And I'm involved in doing the single cell sequencing on COVID-19 to really understand like how does it alters the epithelial cells, how does it alter the immune cells, how does it alter the endothelial cells. So now we can like get a very granular picture so that we can have the drugs with very less toxic profile. So a brief, I think maybe everyone knows this, basically like about COVID-19, it like, mm, like maybe I will skip that one. So its origin, I think there is at least no controversy on like from where it is originated. So it looked like to be, it is a bat virus that either directly make a leap into humans, or it we like through the food it enter into the humans, and now like it is like spreading from human to human. Transmission of the virus is going on. So we are still like a lot of groups around the world, they are trying to figure out like how does this evolution happen, basically that a bat virus jump directly into a human. So like if a bat virus needs to jump into onto human species, they need to have like a lot of adjustments, a lot of ways how do it adapt to the human environment, but somehow like it is thriving very well on human environment. So there is, I think, still a lot of controversy going on, like how does that evolution happen? So we will see a lot of research coming out onto that topic. So what is the current scenario like of the world? Like is the numbers are increasing, numbers are decreasing? So I will maybe like spend 5 minutes on that basically. So as of like 2 days back, there is 5 million confirmed cases of COVID-19. There are like around 340,000 deaths across 188 countries. And United States is one of the country that is very drastically affected by it. There is 1.6 million cases and there is 90,000 deaths in the United States. Despite of having maybe you can say like very well developed healthcare system, very well developed healthcare facilities, it is very, very difficult to control this virus. And if you look at India's perspective, I will say like India is doing great basically. Like they are just like very less number of cases, like as compared to the Indian population, and like very low number of deaths. So I think for that, I will definitely like congratulate Indian authorities, like who really may be able to contain this virus by doing lockdown or by some other measures. And so that I think is a great job done basically. And how does it's progressing around the world right now? If you look at, so like the curve of the United States is flattening. We are now able to like control the number of new cases that are being detected by doing social distancing, or closing the schools, closing the health, all the offices, working from home. Whereas like India, I think still, I think curve is not flattened. Basically, it is going up. But I think hopeful basically that with the current ongoing measures in India, I think they will be able to like flatten this curve like very well. And then only thing I would like to point out, like one of the country that is emerging as a hotspot for COVID-19 now is Brazil, because their curve is going straight. They are like huge number of cases are being diagnosed with COVID-19 every day. So that is, I think, one of the country that is coming up as a hotspot for COVID-19. So if we look at the genomics of SARS-CoV-2, a virus that causes COVID-19, how does it compare to the other viruses of SARS family? Like, so this is not a new family of viruses. They are common cold virus, and they are being here like from centuries. So this is not a new virus. So how does, if we look at its genome, it compare with the other viruses of the family. So it is very closely related with the bat SARS-CoV-2 virus. And this is the novel virus that is first time detected in Wuhan. I'm not saying that it is originated there basically, but it is detected there in December or November of 2019. Whether it spread from there to the rest of the world, there is still a controversy on that. But this novel virus has a very high similarity if we look at the sequence profile of it with bat COVID, like SARS-CoV. And it also have like some similarity with SARS-CoV-1. It has similarity with MER virus, another, but I think the highest similarity it show it with bat coronavirus. And if we look at the profile, like does it change with the time? Like do it show a mutation alterations with the time in last like 4 or 5 months basically? Do it alter its genome? So if we look at that profile, so here we picked up the data from a beautiful resource that is set up where they are collecting the sequences of the virus all around the world. And if you look at the x-axis, that is like December, January, February, all the months this virus has been spreading, and each dot indicate the mutations here. So we clearly see basically that this virus with the time is showing the change in the mutational profile. So that is creating another trouble basically, like is that change in mutation profile, it will hinder the development of effective vaccine or development of effective drugs that we will see in the future. But look like this virus is having some mutations rapidly, maybe to adjust around the world to the environmental factor, to the different races of the human beings. So it is making the mutational changes. The mutation profile, I will definitely say basically it is not at the level of HIV or SIV, which like mutate very quickly. But here we see like some mutation changes going on in this virus. And then one of the thing is like who is more prone to this virus? Like, is the kids are as prone as the adult or the elderly population? So we looked at the data coming out from every day from CDC, and where we clearly see that this virus like severely affect the elderly population, the people above 55, or you can say 45 also. Basically, they are the one which are severely affected. And I think one of the main reason for that, I think that we are learning now when we are dissecting down this data, is that like with the seniors, they have like living in the old age homes basically, so the transmission of virus is easy. And second, they also suffer with a lot of comorbid conditions, like suffering with diabetes, suffering with hypertension, and cardiac conditions. So that is in combination with old age, is making it a deadly combination, that this virus is causing a lot of deaths. So then one of the person working with me, so we start try to understand, like, is this virus is showing any correlations with some other factors? We understand basically that it is correlated with the pre-existing conditions, but there is some other factors which are making people prone to this virus. So we ran an analysis like where we try to understand, is there any association in between malaria and the deaths due to the COVID cases in the world. So we looked at every country and their malaria profile. So like here, x-axis is the malaria profile and the y-axis is the number of COVID cases. So a lot of countries which have like a very low number of malaria cases, basically they have like high levels of COVID-19 basically. And I think these are all developed countries like UK, US, Europe countries. India is one of the countries where there are a lot of malaria cases, so there is less COVID cases in India. So this can be maybe like a association like where developing countries, they are doing less number of tests, but look like from the first analysis that there is a good association in between malaria and COVID-19. If you have more malaria, less number of COVID cases. We also looked at the smoking data, like the countries with more percentage of smokers, and do they associate with COVID-19 cases? Doesn't look like to be any good association, because I heard a news few days back basically that smokers are protected from COVID-19. There is a lot of mechanism proposed behind that, but looking at the world data, there is look like to be no association in between them. So then we looked at like, is the population density and COVID-19, they have any association with each other? And looking at that, like if you look at the population density and look at COVID-19 cases that is shown on y-axis, there's a straight correlation in between the population density and COVID-19 cases. And same is true if we can take in consideration the poverty percentage versus COVID-19 cases. There is a straight correlation, positive correlation in between them basically. And if you look at the GDP, I will say like there is a correlation between like high GDP countries have more amount of COVID-19, and this can be maybe two reasons. One is like the high GDP countries are doing more testing, so they are able to diagnose more amount of COVID-19. That is maybe one straight reason. But the second hopeful reason that I want it to be that the developing countries, people are exposed with so many allergens, so many infectious agents that they have like more repertoire of antibodies which are protecting them against SARS-CoV-2 or COVID-19. So if that is the case, I think that is a good news for the developing countries. But I think we are running a few studies like where we are trying to understand basically like what is the antibody profile of the people across the world to really understand that phenomena. So I think looking at like what are the factors associated with it, maybe like I will summarize basically that the age is one of the key factor, pre-existing conditions, especially I think diabetes and cardiovascular diseases. Those are very significantly associated with it. And then population density is significantly associated with it. And malaria look like to be protective, but like that is a real scenario. We don't know basically, because if we have immunity against malaria, because that is a parasite, how does that protect us against SARS-CoV-2? That is a big question that I think maybe researchers need to answer. Now come to maybe shift gear to the therapeutic, like what are the options we have right now and what is the clinical trials across the world are saying basically. So maybe I will spend next part of the talk onto that. And so this virus basically, like as shown in this like picture, like if it has to enter into a human cell, basically, it needs a receptor on human cell that is known as ACE2. And I also need another protease for making a cleavage that is known as TMPRSS2. So that are maybe the two targets that are currently being explored for the therapeutic strategies for blocking the entry of the virus into the human cell. And then a lot of groups are working on virus itself, basically, like how can they stop the replication of this virus. So I will maybe like go to some of the drugs like that are being like already in clinical trials or approved by FDA for SARS-CoV-2. But before that, I will try to like dig a little bit deeper into like what is going on like with ACE2. So is ACE2 or at the TMPRSS2, which are the two key genes for the entry of virus into a human cell. So is that make sense to us basically? Like, is the cells which are expressing ACE2, is this virus just affect those cells? We looked at some of the data into that area. So if we look at the expression profile in different tissues of human body, like these are all the different tissues of human body, and this is the expression profile that is shown on the y-axis. So you clearly see basically that ACE2 as well as TMPRSS2, it is expressed like by mostly all the tissues. Like it is ubiquitously expressed by a lot of tissues. It's lowly expressed in the brain, but like a lot of other tissues, they are like have a quite a significant expression of ACE2, and that might be the reason basically that this virus is able to enter into the cell types which are enriched in different organs of the human body and can impact the different organs of the body. But if you look at the single cell data, like if you look at the every cell's single cell profile, it looked like that ACE2 is significantly expressed only in the epithelial cells of the lung. That AT2 type of cell of the lung has very high expression of ACE2, and that what I think make the lung as the primary organ where like we see a lot of pathophysiology due to this virus. This kind of plot they call as UMAP plot, and I don't know how many of you are working in the single cell arena, but this is a typical single cell plot, like where each dot is a single cell, and you can clearly see basically that in this plot, like ACE2 is significantly expressed, that is shown by black dots, into the epithelial cells of the lung. So that make, I think, lung as the main organ of that. And if we look at the single cell profile of the people, epithelial cells, like these 82 cells that are coming from lung with different ages, so you can clearly see like pediatric population has low amount of ACE2, that is shown by blue color, and with the age you see an increase in ACE2 expression. And is that increase in ACE2 expression is making senior population more susceptible to the infection from this virus? I think that looked like to be on the mathematical side a good maybe result, but like a lot of groups are working on basically by blocking ACE2, do we see a decrease in expression? But look like ACE2, that is the key gene needed for the entry of virus into the cells. It is expressed significantly in a lung epithelial cell that is known as AT2, and that cells, like if you collect those cells from pediatric population, from the adults, basically from the seniors, look like to be the ACE expression is significantly, ACE2 expression is significantly higher in the senior population, making them more prone to this infection. So right now, I think Dr. Mehdi covered, I think, quite a bit of like what are the drugs, what are the vaccines, what are the diagnostic scenarios are going around the world. So I think if I see like the drugs, basically they can be divided into three categories. Like one is the direct antiviral drugs, like where we are trying to target the end, like a virus itself, the RNA of the virus or the proteins of the virus. And the second is the immunotherapies, because what we're learning is basically that this viral infection, it causes like a lot of cytokine release in the body, like the body is in like a hyperimmune activation state. That is making like to handle this disease more complicated. So a lot of groups are trying like immune therapies, which will block this hyperactivation of immune system. Another name for that is cytokine storm, if they can stop it. And then repurposed drugs, like where we are trying to use like all the drugs like from the viruses of the same family basically, or antibacterial basically. People are trying anything and everything to really control this virus. And then on the vaccine side, like there is development going on for inactive virus or attenuated virus-based vaccine, DNA and RNA-based vaccine. And so my group is focused on repurposing the drugs by using the genome data of SARS-CoV-2 and the drug's genomic profile. So I will go through that. And so if we look at the clinicaltrial.gov basically, where like all the clinical trials are registered. So right now, I think as per yesterday, I think there are more than 800 trials which are up and running, which are recruiting the patients. And if you look at this world cloud basically, where the size of the latter depend upon like how many trials are ongoing for that. So the hydroxychloroquine is the one like for which like the maximum number of trials are up and running. Chloroquine also, there's a lot of trials up and running. Plasma therapy, a lot of trials up and running. Remdesivir is another one where like significant amount of trials are up and running. And so I will go through maybe like what is the like we think like is hydroxychloroquine is helping, not helping, and Dr. Mehdi, like maybe I will present some data that will say like hydroxychloroquine is maybe not looking good, but I think please take it with pinch of salt basically, because a lot of things need to be taken in consideration, how to optimize the dose for hydroxychloroquine and all that. But I think there is a Lancet paper came out on Friday, like where a group from Brigham and Women in Boston, basically, they looked through a registry of 90,000 people across multiple countries. And they looked at the data from 14,000 people who are either getting treatment by chloroquine or hydroxychloroquine, and then try to understand like, is they are at advantage as compared to the people who are getting the standard treatment or who are getting placebo. So if you look at this chart, I think that is directly coming from their paper. It's a Lancet study where like each of these dots indicate like whether something is increasing the risk of the death or in decreasing the risk of the death. So when they looked at that, like chloroquine as well as hydroxychloroquine alone, as well as with macrolide, both the cases, it is like enhancing or increasing the risk for the death. And they have beautifully, I think, shown basically that why that is happening. So when they looked into the various symptoms of these people, like who are having the harmful effects of chloroquine or hydroxychloroquine, what they learned is that looked at that. So they looked at like ventricle arrhythmia is increasing or decreasing by hydroxychloroquine or chloroquine. And what they learned is that both chloroquine as well as hydroxychloroquine is significantly enhancing the ventricle arrhythmia. So that is maybe one of the underlying reasons why they are observing more deaths in both the cases of the patient who are getting treated with chloroquine and hydroxychloroquine. And this is not a prophylactic study. This is done on the people who are all sick seriously with COVID-19. So it might have a different profile in the people if it is given before the onset of the disease, but looking at the data that is coming right now, and I think it's a significant study because there is 14,000 people in the study. Looking at right now, hydroxychloroquine or chloroquine are not helping treat the disease, at least I will say, but whether it will give us prophylactic advantage when the viral load is less, I think that is a separate research question. But right now, this is what I think, looking based on data. So another drug that is got FDA approval is remdesivir. Remdesivir is the drug that directly target the viral RNA for the treatment of COVID-19, and this drug is developed for Ebola virus, but it is getting repurposed for COVID-19. And if we look at the results came out of this drug, this is a double-blinded randomized trial, not like an open arm study. So what we learned is, if you look at the paper that came out in New England Journal of Medicine a few days back, what we learned is that this drug is helping in improving the median recovery time for 11 days for this drug as compared to placebo, that is 15 days. And the mortality rate in the remdesivir treated arm is like 7.1%, whereas in placebo it is 11.9%. But is this improvement is good enough? I think like as a scientist, if I have to answer that, I will say, yeah, maybe not slam dunk basically, but it is giving us some advantage basically. And this is the preliminary data came out of remdesivir trials. But I think much more data is going to come out soon to maybe if they can hold on or improve this 7.1% to much more. I think that will be a great news. So I think that is one of the drug that is FDA approved and look like to be having beneficial outcome for COVID-19 treatment. But I think, as Dr. Mehdi said, it is expensive drug and maybe not there, you cannot treat millions and millions of patients with this drug unless Gilead, the company that make this drug, they will freely give this drug to everyone. So the next topic I will cover is the one of the things I think that is India is trying, all other countries are trying, is treatment by using the plasma from the patient who recovered from COVID-19, because this is not a new technique being in use from centuries, being tried in earlier time when there used to be no vaccine, plasma therapy is the way, I think, to treat it. And my son had made a beautiful cartoon where he said, okay, COVID-19 patient, when they recovered, you draw their blood and find out what are the neutralizing antibody in their blood, and give that as a vaccine or give that as a treatment to the patient who are currently having the disease. There is a primary result that came out of plasma therapy for COVID-19. Look like in a small study, they show basically that it is able to stabilize the oxygen requirement in the people who are treated with plasma therapy, and it is like as compared to a matched controls, and it is also able to like give them a survival advantage. That is like not lot, but I think it is plasma therapy is, as shown by red line, giving them a survival advantage as compared to the matched control who are not given plasma therapy. So I think that might be, I think, one of the best thing to try right now if remdesivir is not available. And then a lot of trials are up and running for anti-inflammatory, or you can say like the drugs which block the inflammation, and JAK inhibitors like from Lilly, from a few other companies are being used for treating the cytokine storm. And most of these drugs, like which are anti-inflammatory, that are being repurposed for COVID-19, they are available for either autoimmune diseases or arthritis. And I think I listed few of them, like which are showing to like have some positive results. Like anti-IL-6, C5, BTK. So all of these like are the drugs which block inflammation or like a hyperactivation of the immune system in like the patient who are suffering with rheumatoid arthritis and others. So like our group is taking the approach like where we are like trying to understand, is that really happening? Basically, like, is viral infection, first of all, is stimulating IL-6? Is it stimulating IL-8? It is that is happening or not? So we adopted this approach in my group, like where we collected the genomic data from the viruses. That is, some of the data is produced at Emory as well as the data around the world. And so we defined the genomic signature for SARS-CoV-2 by finding out what are the changes this virus is causing in human genome. And then we try to understand like what pathway it is modulating. And then my group has a large resource of access to larger source of drug database, where we know that how does the drug alter the genome. So we use that strategy. So let's go here. So SARS-CoV-2, so this is the signature for this virus. Like we are like each of the this kind of plot is known as heat map. So you can see like it alters a lot of genes in human genome. So in the similar fashion, we defined the genomic signature for RSV as well as H1N1, the two viruses which are related family. And then we said like, can we figure out basically like what are the genes which are just altered by SARS-CoV-2 in our genome as compared to other viruses of related family like H1N1 and RSV. And when we did that, so we identified a signature of 93 genes which look like to be SARS-CoV-2 specific. And I'm showing the top genes here, like CSF3 is one of the top genes, CXCL5 is the top gene, IL-6 is one of the top gene, which is stimulated when this virus infect the human cell. Then we went more deeper into it to really understand like these 93 genes which are altered by SARS-CoV-2 in human genome, like what are the pathways, what are the things they are involved in, what kind of functions they are doing. So look like they are mainly involved in all the immune things basically. So I think somehow this virus is stimulating key immune pathways, and that is, I think, not the case with the other viruses. Basically, they don't stimulate like IL-6, IL-8, IL-17 at that level, what we're observing in this virus. So as my group is do a lot of system biology, so we said, like, can we figure out, like, if these pathways talk to each other, what is the key molecule that is driving all these changes? So when we did that, so you will see this right side plot, that the orange color dots. So major molecules which are stimulated by this virus is NF kappa B, IL-6, IL-1 beta, IL-17. If we design the therapies which will block these molecules, they might, I think, can help in the better management of this disease. I'm not saying like that is going to like treat the disease, but just the better management of this disease, because we need to combine the immune therapies with some antiviral to eradicate virus out of human bodies. So we use this approach that we have previously successfully implemented for Zika as well as for staph infections. So we took the SARS-CoV-2 genome, we took the genomic profile of 16,000 drugs, use artificial intelligence based matching to find out, like, what are the drugs which are going to work for SARS-CoV-2. We identified 3 drugs which are like, I cannot show the name for them basically, but these drugs, like, they inhibit most of the key immune molecules which are stimulated by this virus, as shown by the arrows in this like subplot of the heat map. So from MOC to SARS-CoV-2, these all genes are going up, and these drugs are bringing it down. So we are currently running the studies to validate these findings, and hopefully maybe one of these drugs will work for SARS-CoV-2. That is our hope. These are all FDA approved drugs, so we need not to have phase 1, phase 2 trial for them. We can directly enter into phase 3 trial. That is the beauty of this analysis is. So we are hopeful basically that in coming 3 to 4 months, we will have some drugs for that. So this is the story of the drugs, like where we stand with that. So I think I will say maybe like remdesivir is the drug, or the plasma therapy is the current best options available for us. On the side of vaccines at present, as Dr. Mehdi was saying, there is at present 23 companies which are testing various vaccines for SARS-CoV-2. One of the company is that on Thursday, I think they given their like phase 1 trial results from 8 people. The vaccine is from Moderna. This is a messenger RNA based vaccine where they pick up a part of gene of this virus and give that as a lipid nanoparticle to the human. And they've shown that the first 8 people whom this vaccine was given, they developed the neutralizing antibodies. But is development of those neutralizing antibodies is protecting them from infection? No result were released on that. This is just the first phase 1 that they are developing antibodies against a protein of SARS-CoV-2. That is the first test, I think, done in most of the antibodies. But then there's a company from China basically that has an inactivated SARS-CoV-2 vaccine. That is a more traditional vaccine as compared to Moderna. That is a messenger RNA based vaccine where they have shown that in mouse, rat, and in monkeys, they are able to develop the neutralizing antibodies by giving this vaccine. And they are also shown basically that this vaccine protect the monkeys from getting the reinfection basically. So that is, I think, the good news about this Sinovac vaccine. So there are a lot of other companies are developing, I think, vaccines. Another, I think, result came out of a recombinant adenovirus vaccine from, this is also coming out from China, basically, where they did the phase 1 trial in 108 people, and they clearly shown basically that when they give the vaccine, they develop the CD4 and CD8. These are the T cells of human body response. And they also shown basically that the vaccines are really against the adenovirus that they are giving. And so I think that is another vaccine that is coming along. But I think right now, even if they are phase 1 is cleared, I think 6 months away from it. So I think that is the story of drugs, vaccines, based on what we are learning. So I think, so then what is the best approach right now? So I think the best approach, I will say, is prevention. I think maybe like this is the team of my son, they designed this basically. I think the best approach right now is basically like do the social distancing, be 6 feet away from each other, wash your hands, basically wear the mask. That is, I think, the best approach until we have a good vaccine for this virus. And that is, I think, I would like to say. And in the end, I would like to thank my group as well as the groups which are Suthar group, who is testing our drugs, Vikas group, who is also helping in pharmacokinetics of these drugs, and the funding agencies who are giving the money for doing all the work that we are doing. And this cartoon, I think, beautifully demonstrate, like, if you can stop at least 1 or 2 infections by staying at home, you can kill the whole propagation arm. So please do that. I think that will be the best scenario. Yeah. Thank you very much.
Yeah. Thank you, Dr. Bhasin. It was a beautiful, wonderful, excellent talk. You covered the entire aspect of COVID-19. I think mainly the students would have benefited a lot from this. This is something which they've gotten as an update. Really very informative session. So I think there are lots of questions pouring in. We will take this after the panel discussion. So we have one more talk lined up. Then we'll go into panel discussion. So please stay back for the panel discussion. So you can mute yourself and stay back. And finally, all the panelists can join. Now I'll request to invite the 4th speaker for the today's expert talks. We have our Honorable Pro Vice Chancellor, Professor Atul Khosla with us. Sir, are you there? Yeah. Very good afternoon, sir. Welcome to the session again. After having the technical part of COVID, now we want inputs from you. So he would talk on socio-economic aspects of this COVID-19 pandemic. So over to you, sir, without wasting any more time. Thank you.
Thank you, Anuradha, and thank you all participants, and thank you, Manoj. What a wonderful talk. I think this was extremely informative, and wish your team great luck. I'm sure you'll find the vaccine or you'll find the medication for COVID. I'm not a blue-blooded economist, but I spent 25 years of my life understanding how businesses operate. As a quick introduction to many people who might not know me, I'm a BTech from IIT Kanpur. I then did my MBA from a school called Bajaj in Bombay, and then spent more than 20 years in the industry, especially in management consulting with firms like McKinsey and Company. And the area that I predominantly worked with at McKinsey and then later on with Oliver Wyman was broadly 3 things. First was healthcare. So I was a core member of the healthcare team, and I served clients like Novo Nordisk and Novartis when I was at McKinsey. I used to work with a lot of banks, which means I did try to understand how economies and financial systems operate. And finally, I was doing a lot of work on public policy. which also how regulators typically react to these type of situations. Never been through a crisis like COVID, but I've been through two big shocks in my life. One was in 01 and 02 when the big internet bubble burst, and there was a big economic crisis at that point of time. And finally, in 08, 09, as you were aware, there was a big banking crisis that happened, which we navigated at that point of time. So what I'm going to present today, and I don't have a presentation, but I'll speak today, will be about my thoughts about how things will span out in the next 2 to 3 years as we look at the socioeconomic impact of COVID or coronavirus, as we call it. So I'll try to leave 4 to 5 thoughts with all of you. First, as you're all aware, the world is not going to be the same as we left it. It's going to be very different. I'm going to make some hard statements over here, so please bear with me. I think the first and near-term impact is that there's going to be a very sizable impact on the economic growth of every geography across the world. I also believe from my numbers and my analysis that most economists have yet not estimated the complete impact of COVID. Most of them hover around a neutral impact of GDP growth. So if you look at IMF numbers or World Bank numbers, they'll put Indian GDP growth at anywhere between 0 to 2%. They'll put US growth at -2% and similar numbers for Europe. I think the first thought I'd like to lead all of you to is that the impact of Corona is going to be way, way, way severe. I anticipate anywhere between a 5 to 7% decrease of GDP for India and around a 10% GDP globally. So what does that mean for all of you? It means there'll be lots and lots of jobs that are going to be lost. There's going to be a new economy that comes up. And finally, there'll be a lot of incentives given by the governments across the world to reinvigorate these economies. A -10% shrinkage of the economy, if that happens, is something that we probably saw in the 30s and the 40s when either World War was happening or the Great Depression was happening. We've not seen any such collapse in the near future, in the near past, sorry. So why are the stock markets going up? You will ask me, why do we see a recovery of the stock markets? And the answer is very simple. A, there is a retail money coming in. So a lot of people like you and I are investing in the retail markets, in the stock markets. And the second thing which is happening is that there is still a lot of optimism. People, human beings by definition, are optimists. So they're assuming that Corona will go away and the markets will come back. So let me build my case as an example. We have yet to see Q1 numbers from the Indian context or Q2 if you look at Europe or the US. And as these numbers start coming in, you'll see some negative messages coming through. So be aware of the fact that there's going to be some challenge on the economic front. So that's one. The second thing is that whenever any such disruption happens, there's also a fundamental change in the way organizations, companies, or people behave. And 3 things might happen. First is the freeway of global economy that we had over the last 20 years might come to an end. So you'll see more insular economies. It's like our dear Mr. Modi, our Prime Minister said, we are going to be Atmanirbhar. The same thing is happening what Donald Trump is saying. He's saying, I do not want Chinese goods. I want to manufacture in the US. Europe is going to say the same. So global trade might actually not grow at the extent that it has in the past. So you'll see a decrease in global trade. So that's the second trend that I perceive. The third thing, which I'll say, is a little bit of good news for India. If China is seen as a bit of a culprit by the world, there's going to be a movement of manufacturing from China to countries like India. And it's the opportunity for India right now to introduce superior infrastructure and superior capability to capture those opportunities. So manufacturing might go up. But there's another very big challenge. The Indian service industry has been driven by our technology industry, as you're all aware. Infosys, TCS, Wipro are the stars of the technology world. I see a major downslide for these technology firms. The United States or Europe, which are the big buyers of these services, are most probably going to say no to them, which means there's going to be a major joblessness for people in the technology sector in India. These people will have to upgrade themselves, upskill themselves from Java and other low-end technologies that they use to higher-end technologies like machine learning, AI, and the likes. So these will be economic changes. Let me repeat. First, there's going to be a sizable decrease of GDP. So job losses will happen across the world. Secondly, there's going to be a decrease of global trade. So globalization that we have seen in the past is not going to happen. If you're planning to go and study in a foreign country, or you're planning to work in a foreign country, that's going to decrease to quite some extent. May not even happen. You might not even get the visa. That's a second trend from an economics perspective. Third, global supply chains will change, which means manufacturing bases will change. Anticipate a move from manufacturing from China to India, a big opportunity for India. However, we do not today have the infrastructure to capture this opportunity. Let's see if the government can pump money and build that infrastructure. Lastly, as I said, our big services industry, which is led by technology in India, is going to see a major reshuffle. The challenge is on us as Indians. Can we move from low-end IT services to higher-end AI, machine learning driven services? So that's what's going to happen at the economic level. A few other industries are also going to do well. Pharma, for example, pharma manufacturing out of India is going to do very well. So that's another good spot. Education, what's going to happen in education? You'll see lots of technology-driven education happening in the future. In fact, a friend of mine has already started talking about a global university. Why should there be geographic boundaries when it comes to universities or colleges? Increasingly, research will become more global, where there'll be splicing of the value chain of research. And I spoke about this when we started the seminar. You do not need to do research at one place. Manoj's lab doesn't have to do end-to-end research from hypothesis development to analysis to publication. They can splice the value chain. For example, they can give the experimentation to labs in Shulani, for example, or analysis to labs in Shulani, or the Shulani scientists, for example, can give their hypothesis and their experiment over to Manoj's lab, who can then conduct the analysis and take the research forward. So expect consolidation, major consolidation on research to happen. On the social front, of course, it's a big challenge. We'll all have to learn to live very differently. We'll have to learn away from each other. So this whole extent of collaboration that we're talking about is going to change from collaboration in a room to collaboration over the internet, something that we're seeing today. Travel is going to come down in a very sizable way. So airline firms and tourism firms are going to be majorly impacted. And it's going to be a very different world that we live in going forward. I'm really talking about the near to medium world. What's going to happen in the long term? I think you'll see new devices coming up. For example, speaking over bad internet is tough. Using these type of headphones is not the best thing. Our screens give our eyes pain. We'll all become zombies, or zombies as they call it. So there are going to be new devices for interaction over the internet. There's going to be major investment in technology. There's going to be stuff that we all read, all we've read in science fiction. So be prepared for that. If there's one last message I'm going to give, in fact, I'm going to leave two messages for all of you. The first message is going to be, please upskill yourself. Prepare for the future. Value for all of you is not going to be doing mundane things, but going to be doing things which are up the value chain. A small example is, if you're into research, the value is not going to be doing the experiment, but the value is going to be in the analysis and use of data. Like what Manoj was presenting, as I understood, a lot of that data might not be his. A huge amount of data exists across the world. Can you as scientists use the data to come up with great research? It's up to you. Can you upskill yourself? Or are you going to go back to your lab and do the same chemistry that you were doing 20 years ago? It's going to change fundamentally. The second message I'm going to give, apart from upskilling, is that please be safe. It's a very high chance that at least in universities, the way we teach is going to change. So do not expect to come back to campus and teach students the way it's happened over the last 1,000 years. There's going to be a fundamental change in that, because personally speaking, I do not see next semester happening on campus. It might be some trickle here and there, but there's going to be a difference in the way our education has happened over the next one semester at least. And if one semester happens in a different way, who knows what's going to happen in the future? There's going to be democratization of learning, which I think is great news for people in India and bad news for people who sit in ivory towers like Harvard and other large universities. So the last message from a social perspective is be safe. You need to, it's a long marathon. It's not going to be a sprint. It's going to be 6 months, 12 months, 18 months. And Manoj was predicting coming out of the vaccine. Who knows? So be prepared for at least a 12-month run. Do not exhaust your energy in the next 2 months. Be prepared for a 12-month, 18-month run. It's a marathon. Preserve your energy, build your friendships. Don't exhaust yourself, but more importantly, be safe. With those thoughts, once again, thank you very, very much, everyone. Thank you, Dr. Anuradha, for a wonderful workshop. Thank you, Manoj, for an amazing lecture that I saw. And we'll be open to questions going forward. Over to you, Dr. Anuradha.
Yeah, thank you, sir. Thanks for the very nice insights, very brief and reality. That's what we have to all live towards. So we are going towards a totally new life forward. So you gave a very nice kind of a list of points. So I think all of us should note this. That is a reality which we are going to live in. But definitely we should cope up with this. So we'll come out with solutions. So hopefully this workshop will throw out lots of ideas for the students, how to shape up their life and their careers. So thank you, sir, once again. So now we are done with all the expert talks. So we'll be moving to the panel discussion now. So I request all the panelists to turn on their video and audio. So we'll start the panel discussion and take up some of the questions from the audience, maybe not all of them. I'll just wait for a few seconds. Maybe all of you turn on your videos and audio. Okay, so good afternoon again. So welcome back to the session. So we are ending the third day session of this symposium today. So we had wonderful talks from 4 experts.
I think there is some echo coming. Someone probably has 2 devices on. Apologies for interrupting, Anuradha. So we can probably all mute ourselves as panel.
Okay, I think it's better now.
Yeah, now it's
Yeah. So we had the start of the session with the lecture on devices technology for COVID-19. That was from Professor Ashutosh Tiwari. And then Professor Bikash Mehdi put in insights on diagnosis and treatment. So typical the pharmacological aspects and what is actually happening at the patient level. And then we had talk by Professor Manoj Basin. So he covered the entire aspect of epidemiology, diagnosis, the vaccines, and the therapeutics. And he also gave in a lot of case studies where the current drugs are actually turning out to be possibly not safe. So we'll take up discussion on this. And lastly, we had our Pro Vice Chancellor, Professor Atul, who actually threw in insights on the economic aspects. So now we'll go into the panel discussion. So the first aspect I would now put in as a question to all the panelists is now we are all working to get out of this pandemic. So what would be the future implications for the post-COVID world? Very soon, we hope that we exit out of this COVID pandemic and things would start now weighing getting down, and we should be planning for an exit strategy. So in terms of each of your expertise, I would now like to have your comments and feedback on what are the future predictions for the post-COVID world. If at all we come out with the vaccines and then we all go back to work in a normal way, possibly working with all the safety strategies of social distancing and all. So I would start with Dr. Ashutosh Tiwari. So what would be your thoughts on this with respect to the technology, and maybe what AI would play a key role, and what kind of role would it play?
Yeah, thank you. So basically, for now, we learn about the hygiene. We want to somehow create a distance. So basically, technology all the way going to be create a sort of assurance where you are going, what you are doing, and even hygienic, even in the society, if you are going somewhere, you're supposed to have, some sort of tools which might be help you to not get any infection. So for example, I'm giving one example which I have seen when I was in Japan. So in Japan, there was a very normal practices, because in Japan, mostly offices having a common access. So more than 10 people or even more, people work at one place. And there was a ethical concern if somebody is sick, that guy is supposed to wear a mask, or might be inform the colleague, okay, today I have fever or I have some flu or whatever. In case somebody is having a severe flu or severe problem, breathe problem especially, so they inform and not come to the office. It was a normal practice which I have seen. So in this pandemic situation, we are more aware. Okay, we supposed to have a reliable location to work, to go, or even if we are using a public transport or public places, we might have a certain assurance. Probably technology can help. And I'm sure AI, machine learning, even IoT tools going to be much more even. I heard about Atul said, this is going to be, we need to be update ourselves. So I think cloud health, which I have addressed in the very beginning, where the cloud technology, especially coupled with the AI or machine learning, they are going to be much more stronger in the coming years. That's my understanding. Yeah.
Yeah, thank you, sir. So now I'd move to Dr. Mehdi for his comments. So in terms of the therapeutics and research and pharmacology, what do you think would be the future era after we get out of COVID-19 pandemic?
I think another 6 months we'll learn a lot. All the data will come, but particularly vaccine, if we are successful, definitely we can get rid of this problem. But still then, even if you have potential vaccine or drug therapy, we need to also understand that all these precautionary measures like PPE, what we learn over a period of time, need to be practiced for a long time, because it's not immediately going to end. We do not know second wave or third wave. Like for example, in Singapore, there was a lockdown, then second wave came. So these also need to be looked at, and also the infrastructure and the quality of devices. So all these points are important, but mostly they're concentrating on the vaccine development. If it is come, then I think major problem will be solved. Thank you.
Right. Yeah, okay. Thank you, sir. Now over to Dr. Manoj Basin. So what are your thoughts, sir? So you can give a more global overview. So you're sitting in the United States. So what do you think would be the global overview of future post this COVID pandemic?
I think, like, first of all, I think like COVID had made us to think, basically, like what we used to think, that we have a very well-developed healthcare system, that is not there. Okay, so I think we are reinventing now the healthcare system. like where all the supply chains are aligned so well, basically, that we can like go from 0 to million mask production in 2 days or 3 days. That was not there in US. And I think India is in the same scenario, basically. Like this is making us to reinvent how do we do the healthcare, basically. In US, I think a lot of healthcare is ongoing, like where we share our data, AI is combined in drug discovery, vaccine development, basically. But I think not at the level, basically, that is needed for this kind of pandemic, basically. So I will say, I think good thing that is going to be come out of COVID is we are going to develop a new way of maybe doing the drug development, vaccine development, as well as how to prevent the spread of this kind of virus, basically. Because now I think all the big companies like Google, Apple, who are developing like the contact tracing devices and all these things. And I think if we would be able to like have those devices on hand, basically, like which can trace the contact, basically, I think this pandemic would not have been there, basically. So I think in initial phase, we thought maybe that, oh, this is a simple virus. The information was not transmitted in a proper fashion by all the authorities. So I think if the flow of the information is more streamlined, then we have lined up like information technology, healthcare technology, as well as all the supply chains. I think that will give us a maybe new healthcare system where these are going to work more cohesively with each other. And I do see that in the United States right now, basically, because right now, like if you look at, we are collecting all the data at one place. We are collecting the data from across the world at one place, basically, so that we can really understand like what is going to be the what are the factors which are associated with that. And then I think another thing I see is basically like right now we are using repurposed drugs, the various ways like to really treat our patients immediately. But what are going to be the long-term health outcomes of that? We have never thought about that, basically. I think, so this is like COVID-19 is going to leave a long trail behind it, basically. So, but I think economies are going to come much stronger. Healthcare is going to come much stronger with that. So that is my belief, basically. So that's what I think. Yeah.
Thank you, Dr. Bhasin. So we have amongst us our Honorable Vice Chancellor, who carries a huge experience with him as an academician, as an entrepreneur. And now his aim and vision is research. So good evening, Dr. Khosla. I would like to pose this question to you. So what are your thoughts on how Sholini will look after the future when we exit out of this pandemic? And in general, how would education, the scenario change in India? So the Indian system again is governed by the lot of riding factors from the government agencies. So how do you think and how fast will we adapt to the new changes in the education system?
Good evening, everyone. Mr. Atul, the Pro-Vice Chancellor, has already talked about the scenario, how COVID-19 is going to affect the education system, the researches and the social aspects. You see, I take this as a very complex issue because it's not my subject, but a student of biology and basically a cytologist and who has now in administration. I just understand, or I was reading this, this corona is very complex. It has 5 types of challenges as far as genome is concerned. We have the 1 type, the DNA, double-stranded structure. It has RNA, single strand, double strand, DNA, and 2 + 2, 4, and both RNA and DNA. So if the issue is to be tackled, it is tackled at the genomic level understanding, but it is going to mutate very quickly. It's very, very complex from my angle. Even if we find the vaccine, it will not be for 100% possibility of the situations. it calls for a lot of research. And though in universities like Shulni, there are microbiology schools, but nobody is working on this respect. Time has come when large number of the scientists have to put up their tools. And as Atul has said, it is a time of multidisciplinary approach. Today, corona virus research calls for the medical surgeons, medicine people, biochemists, microbiologists, all type of biologists, biotechnologists, and then crossing the boundaries. You have the artificial intelligence, there are electronics people, social scientists, mathematician. Dr. Dinesh Singh, a former Vice Chancellor of Delhi University, gave us a new concept, which is again required to be tested. That in his analysis, many people are not going to die in India because we are all BCG vaccinated. And he said, and it is his analysis that he has analyzed from the countries where the BCG vaccination was there the death rate is less in comparison to the Europe and America. Many issues are now coming up. We are in the exploratory stage. We need to understand it. And as you say, what should a university do in research? We have to change our thought process. We have to start from somewhere. I wanted Dr. Aslam, the advisor of the Department of Biotechnology, to be with us. It was overlapping with his dates anyway, but he told me, Dr. Khosla, कोई project दो कोरोना के ऊपर, वायरस के ऊपर. अब है, आप मुझे कहते रहते हो कि हमारी हेल्प करो, आपने हेल्प लेनी है, तो जल्दी मुझे कोई नोट भेजो. So this is going to change. The government of India wants more projects, both basic, applied, whatever it is, analytical. Every time, large numbers of people have to join hands. No, it is not the, firstly, we Indians are not tuned to collaboration. There's very little collaboration at the institutional level, within the research labs level, though something has started. But now it is calling for more different disciplines and more becoming more global. This is going to be very important. And obviously, the education system is also going to change, as Vice Chancellor of the university has said. Well, at Shulni, when the first lockdown took place, we had the technology. We had our own indigenously in the university developed system, which we call as the ARDU, the Skandar software. So we could put to test. That was also a challenge for us. When we improved it, it still requires more improvement so that we can compete with the standards of the Zoom or the other global standards. These are the challenges for everyone. Education, earlier I was believing like anyone else, that yes, in 2-3 months, the corona will go away. And it's just like influenza or other virus. So it is a short time, I would say, the impact may be there. But as far as the education is concerned, the universities, colleges, and the schools are the last to be opened, particularly the universities. In a university, you have students from the country. For example, in Shulni University, you have students from 28 states of the country. This India, most of the India is represented in our university. Then there are foreign students. Unless the whole of the country is green, how would you accept the students? And then, even if they come, where are the facilities to put the 60 students in the class or 100 students in the class? You will have to separate them. One group is in the hostel, another group is in the classroom. The whole thought process is going to change. As we all know, it is going to kill the jobs in the market. Who will be preferred in job? The MBA with the knowledge in information technology, MBA with knowledge in artificial intelligence, MBA with a little bit of knowledge of biological sciences. The people will start thinking, the companies will also change their search process, their appointment process, because as we said, that pharmaceutical industry has not been affected much in India. Yes, it has not been affected. So such things will come up in the India. India can also become the hub of the research, and this is an opportunity. And then lastly, I also advocate that the quality of the teaching will improve. The way today you have in this 3 days seminar, you have about 10 speakers, all from different countries. Could you do it if it was not through the technology? The technology has brought today the best experts for this seminar. So same way in the classroom, there can be a Harvard professor teaching us. So Indians are going to do, we are very good in this type of things, I can tell you. We can adopt things very quickly. And I think if we adopt it, then our quality of education will be at par with the global best universities like Oxford, Cambridge, Stanford, Harvard. Why not? Same thing will be there. So, and education also, the global boundaries will break. And whosoever takes the lead, he will be the winner. So Atul was telling me, we say that Darwin has said, struggle for existence. He said, no, the struggle is for the quickest. How early and how quickly and how fast you can do it. So the changes are bound to come. Students also have to learn. Students have to shed away their old stereotype of impression. हमारे बच्चे क्या कहते थे कि जी हमने तो एमएससी केमिस्ट्री करनी है, माइक्रोबायोलॉजी करनी है, हमें सोशल साइंस क्यों पढ़ाते हो, हमें ये क्यों करते हो? Oh, those students at that time were not understanding. Education does not mean microbiology alone. Education will also mean the understanding of the courses in engineering. We are very lucky. We have a pro-vice chancellor, which is who is a graduate from IIT Kanpur. He introduced these things, and this was generally a complaint to the vice chancellor. उनको समझा बुझाकर मैं भेज देता था. But they have to change their attitude. Now the time has come. You have to learn everything. You have to become multidisciplinary. The students are here. With biotechnology or microbiology, you should know everything, whatever you can. You must do some add courses, everything from the Moodle. Whatever you can do, do your best. Become multidisciplinary approach. Then there will be jobs for us. Now gone are the days, as has been said, that you want to go to USA. People create the situation where the people come to India, as in the days of Nalanda or Takshila or other universities were before the 12th century. Because that was a time when our education system was destroyed by one single person, Mukhtiar Ali Ahmed. He was a Turkish general. His passion was won the Indian education system, and for long 10 years he did it. We entered into the dark period of 650 years, and then the Britishers came. They introduced. So what we are, British English and European science. We have to explore our own books also. Everything is written there also, and maybe in a better form. So change is the future challenge. Thank you very much.
Thank you, sir. Thank you for the enlightening vision. Experience always has a upper edge. So you have seen the world much more than anyone here. So I think this has given us a bird idea.
Anuradha, I belong to the time when going abroad was really a very great thing. जब मैं ऑक्सफोर्ड गया था, मुझे छोड़ने के लिए 72 में रेलवे स्टेशन में 60 परिवार के सदस्य पहुंचे हुए थे, 60 people from my family. 15 मिनट में उनके पैरों को हाथ लगाते लग गए. Look how the change. By the time in 3 years when I came back, the scenario had changed. Every year I have seen the change. Those were the time. We need not. We will go back to that type of period. Or why should we go when the your online system is there? There's no need to go. We can have international collaboration. Right through the virtual system.
Yeah. Thank you, sir. Thank you once again. So now I will have the next question for our Pro-Vice Chancellor, Professor Atul Khosla. So you gave us a very good kind of guideline for the economic impact. So now you raise the questions. Now I would ask you, how do we recover from this economic fall down? So what do you think would be the recovery rate of our GDP or in general our economic path, and how do we do it? What are the path which we can take and the challenges? So if you could take
Anuradha,
this.
I wish I knew the answer. If I knew, I'll be a billionaire because I'll be investing in the markets. I think it's anyone's guess. But I think 3-4 things we do know. The first, like I did say, is that there are certain industries that will fall on the wayside and certain industries will grow. So there's going to be a major change in the way we work. So in the near term, for example, brick and mortar entertainment related things, for example, going to cinemas, traveling, holidays, will have big challenges. And till there is a clear vaccine, and at least there is some herding that happens in terms of vaccination, which I see, and my anticipation is at least 18 to 24 months. Of course, I'm preaching to the popes over here because you guys know it way better than I do. You don't expect many of these industries to emerge wherever people have to come together in person. I think there's going to be a challenge. So I think that's very, very important for us to note. Having said that, I think human beings are extremely resilient. Human beings find new ways to create economic activity. For example, I remember, me pushing all of you to say the future is going to be online. I don't know how many times I would have given that lecture to all of you, and many of you, I know for a fact that many of you laughed at me on my back. But suddenly COVID happened, and it's not just happening with universities. It's happening even at rural schools. I was speaking to the son of a security guard, and I asked the security guard saying, how is your son doing? Small kid goes to a village school. He said, sir, aajkal to bachcha bahut busy hai. He has no time. Online education ho rahi hai. So adoption that has happened through COVID is transformative. So coming back to your question, how quickly will it take to come back? I don't think it's going to be an immediate rebound. Typically, I think it's going to take to come back to last year's numbers in pure GDP sense. I think it's going to be a 24 to 36 month recovery. But the next year is going to be very painful. And I think it's very, very important that all of us keep our heads on our shoulders and our minds and hearts at the right places, because it will be very, very painful for many of us. So if there's one message I'd like to give all of you is preserve cash, preserve your savings, don't spend them on, definitely not the stock markets, unless you're a big trader. Preserve them, because many, many people, like I again say, will see a shrinkage of earnings in the future, at least in the next 12 months. The positive thing is, for especially the students on this seminar, this is your moment to become an entrepreneur. If you've always wanted to go out and start a new business, this is your moment for 3 reasons. You can do something which is transformative, something that you've always wanted to do, because the world wants new things. And none of us know what these new things should be or would be. So you can experiment, you can come up with out-of-the-box ideas and really succeed. Secondly, the government is giving huge amount of money across the world to promote new businesses. So if you want to go out and get a bank loan, for example, this is the moment for that. The government will give it to you. And lastly, great talent is available. I have at least 200 great CVs in my inbox from professors across the world, because people are losing jobs. So if you want to be an entrepreneur, what do you need? You need great people, you need capital, and you need an opportunity and an idea. And all the 3 are available right now. So my one message to all of you students is, if you've ever dreamt to have your own startup, to be an entrepreneur, this is your moment. You're all young. There's nothing for you to lose. And I can also tell you that tomorrow, if you want a job, and I am the one who's interviewing, and there are millions of people like me who will be interviewing you, will prefer failed entrepreneurs compared to successful salaried people. I'll any day go with a failed entrepreneur, because the guy's guts, and he's gone out and implemented something that he wanted to do with a great idea.
Yeah, very true, sir. Thank you so much. I think students would be learning this, and they should follow this path. We have an institution innovation council already in our Shulini University. So I think students should take help of this council, and at least are the Shulini University students, so they can take their path so that they can become independent, and of course make their host institute Shulini proud of their achievements. So thank you, sir. So we have one more panelist, Professor Kamal Dev from biotechnology. So far we got all the clinical aspects and the economic aspects. So Dr. Kamal, I would now pose the same question to you in terms of the research. And at Sholini, we do a lot of research on phytomedicine and microbial diversity. So how do you think the research of phytomedicine and microbial diversity would come as a rescue towards the COVID-19 pandemic?
So, hello, good afternoon, everyone. These were wonderful talks today explaining the different aspects of COVID-19. And I think all of us have gained a lot of knowledge through these three different talks, which cover the all aspects of COVID-19. And so my feeling is that these viruses, as we have been talking, they have been living with us for centuries since the evolution or the human being came into existence. Not only these viruses, but the other pathogens, other microbes, whether they are bacteria, they are fungi, they are plants, they are animals, we have been living together throughout. Okay, so what suddenly has actually changed some of them actually to break these barriers and start invading each other. Like now we have the problem of these the animal viruses invading human beings. Okay, and luckily we don't have any plant viruses which are actually getting access to the human beings. So I think the big problem, what I feel is that somehow we are actually destroying the natural habitats, or somehow we are playing with the natural habitats. Okay, so that way actually we are breaking these the barriers and allowing these the viruses jump from the distant animals. Okay, so that is one of the very important point. And what I would like to say is why actually these the animal viruses are jumping to the human beings. Okay, are we human beings are more compromised, or these viruses are becoming more smart? Okay, not only this virus pandemic, you know that most of these pandemics which you see all across the globe, they are not actually natural. There is a contribution by the human beings, or the contribution by the society. So how we can actually take these challenges? Can we have actually break these barriers? Can we stop this spread of these coronaviruses to the human beings? So this is not only the coronavirus. We have coronaviruses since millions of years on this earth, and we have been living together with these viruses. So how these actually they are increasing more pathogenicity? Like we have corona long back, then there is a SARS, then there was a the respiratory viruses, which are influenza viruses, and now we have this the COVID. So this is COVID is more severe as compared to the other viruses which were there in the history before. So what is it the human being is getting neutralized or compromised, or are these viruses are becoming more and more stronger? So the question I think we should be asking, why these viruses are jumping much faster and they are becoming more pathogenic? It is not only the viruses. The problem is more like we all know that the antimicrobial resistance or the drug resistance, that is again a huge challenge. So how to stop these emerging the bigger threat to the human population or to the society? So my feeling is that the 21st century is the century of microorganism. Whether you talk about the useful microorganism, like we have been talking in the even 3 days symposium, the gut microbiome or other useful microbiome, which are going to actually help in many ways actually to stop this pandemic. So that is the story of the good microbiome. And there are bad microorganisms, whether they are bacteria or they are viruses. So how these actually, so these bad microorganism or the pathogenic microorganism, they are just handful of them. They are there in the society. But these good microorganisms, like yesterday or day before yesterday, we were talking, there are more than 1.5 kg of these good microorganisms which are associated with the human beings. So there is a story. There are two sides of the same coin. Actually, one is the positive side how these good microorganisms can be actually used in order to maintain or in order to sustain the human life or to keep us healthy. On the other hand, a couple of these microorganisms, a bunch of these microorganisms, how they are overtaking, how they are overpowering actually the millions and trillions of microorganisms or our own cells in the body. So I think there has to be multi-directional approach in order to cater this the COVID-19 pandemic. The one is obviously what we have been talking is the vaccine. Okay, but vaccine, you know that it is going to be a very long journey, very expensive, and you know that till today we don't have a very big pipeline in the clinical trials. You know that when we talk about just 200-300 molecules in the pipeline of the second or the third phase of clinical trial, that is nothing. We may not even succeed having a one molecule which is going to cure. And moreover, whatever vaccine we are talking, you see that Dr. Vashin said that there are a lot of mutations which are taking place, maybe even more than the HIV viruses. So how do we actually have these vaccines working for the every person or every society? We may end up with whatever vaccine we may get. We may end up with maybe specifically tailored made or maybe a subset of populations. The particular vaccine may or may not work for each and every kind of populations if we have this mutation rate building up at a very high rate. Okay, so so what we need to do is we need to build up this actually the clinical trial, the pipeline, the drug discovery pipeline has to be actually pumped with a lot of these molecules. So, but I feel that one is obviously the traditional approach of vaccine development. Okay, that is taking its own pace, but we need to provide actually these more molecules, like Dr. Mehdi said, the in silico approach, how we can actually identify molecules which can be actually put into the clinical trials. Okay, so that we build huge library of these molecules which are there either in the clinical phase 1, phase 2, phase 3. You should have actually spread over thousands of different molecules at each stage of these clinical trials. Then only we see a little bit, I think, success story in order to control this pandemic. And other thing which I tell there, so one is obviously the vaccine. The second is going to be, I think, the phytomedicines. Like, you know that till today we have even the drugs like artemisinin, that is for anti-malaria, and even Taxols. There is no, till today there is no even substitute for these medicines. So maybe I believe that some or the other way, the molecules from these plants, the traditional medicine plants, are going to make forward, are going to contribute in a bigger way. Like we have actually many, like in India, the Ayush is working on this, even Baba Ramdev's research laboratories are working. So there are many traditional molecules, you know that the Indian system is so rich that we could actually contribute immensely in order to develop, in order to feed this drug discovery pipeline with many new molecules which were not there before, or which are going to actually control this pandemic. So 3 ways. One is actually looking at this, the drug discovery at the vaccine level, and the second is going to be actually this, the phytochemical waste. Okay, whether you come to the in silico techniques or you come through the natural extracting these molecules and testing either in vitro and taking them to in vivo and taking them to the clinical trials. And third one is going to be, I think, the repurposed medicines which we have been talking for the past three days. And today when Dr. Vashin told so many molecules which are there in the repurposed line. Okay, so something is going to come out of that also. So I think it is the century, to 21st century, the century of microorganism. But how do we balance this, the large number of good microorganisms we have in and around us, and a bunch of microorganisms, a couple of or a handful of these microorganisms, how we can actually control? So we have actually a system in place where we can control this large number of these different microorganisms with multi-directional approach. So I think my feeling is that if scientists all across the world start working on different aspects, so definitely something is going to come out of this, and we will be actually solving the problem of this COVID-19. But not only this, we should be ready. For example, right now our focus is on COVID-19. Okay? But I'm very much worried that there may be another viruses, or there may be emergence of another problem, another viruses which are waiting. There are many coronaviruses which are waiting actually in order to jump from these animal to human beings. So once we have maybe the vaccine for the COVID-19, we may have another problem. So that is why we have to plan, we have to prepare, and we have to keep this drug discovery pipeline highly active. So not only one country, but all other countries should keep it active. So now, if we have even vaccine also, we don't know who is going to get the first access. So that is again a big problem. Whether the developed countries, definitely they are going to get the first access. Whether the country like India is going to get the access for these kind of vaccines, which we are talking about, they are in the clinical trial phase and 1 and 2. So the developing countries like India, they should have actually another approach building up. Like we have the Ayush, which is coming up with new molecules. So we should feed actually these molecules into drug discovery pipelines, so that even the other part of the country or the scientists start looking at India, that definitely there are other molecules which can be actually put into the drug discovery pipeline. So that is what my thought about this vaccine development.
Okay, thank you, Dr. Kamal. So it was a nice insight from a totally other angle of COVID-19 therapeutics. So we hope that we all can collaborate together. So we got a huge thought coming up from very, very different aspects of the scientists who are working on either vaccines, either the therapeutics, the pharmacology, or systems biology, and of course the AI technology, which came from Dr. Ashutosh, who was talking about this. So I think we had a very wonderful session. So we are really running late in terms of time now. So there is a lot of pipeline of questions which have been put up in the question answer session and chat box. So these would be shared to the panelists, and please try to answer them so that we can send it back to the participants. So I think at this point, I have two more people joining the panel, Dr. Saurabh and Dr. Dinesh. So if you have any questions for the panelists, you're welcome to raise the questions. So then after that, we'll end the panel session. Dr. Saurabh, please.
Thank you, Dr. Anuradha. So I think we are already late to end this session. So my very small question is for Manoj. Manoj, so you talked about hydroxychloroquine, and so we are also reading tackling COVID-19 for many reasons. There are other therapies, or there are other medicines which are also coming up. So there is one which is called as IV Mercetin, which is, I think, a deworming medicine, and there are a couple of experiments done, I think, in
Ivermectin.
Ivermectin. So it is in Bangladesh and some other countries. So what is your thought on that?
No, this drug was actually tried in Australia in collaboration with one of the CSIR lab. I think over to Dr. Manoj.
I think maybe Dr. Mehdi, you are in the best position to answer this question, maybe. Because I saw that story basically, but I don't see any data behind it basically. And until and unless they're going to release the data, we're not going to believe in that. So I think, like,
in this study, it was found to be promising. And then people in India also, they have done the in silico study also. Then if you look at the clinicaltrial.gov.com, it is one of the drugs to be considered. But only thing is you have to look at it, the dose selected, how much it will be toxic. That is one point need to be addressed. And there are a number of clinical trials. I think 15 days back I checked it, but some of the center it is recruiting, some are not recruiting. So it will take another 2 months to make a conclusive report.
Yeah. Okay. Thank you.
Dr. Dinesh, if you have any question.
Good evening, everyone. My interest is in cloud care health. I agree with Professor Ashutosh. Cloud healthcare is going to play important role in pre and post corona infection tracking. And cloud healthcare is one of the new research area. So one of the hurdle which I think is that how we are going to make use of diagnostic through cloud care to benefit rural areas of country with limited internet access. And one of the challenge with the implementation of cloud healthcare is data breach in terms of health insurance, portability, and accountability. And another concern is whether to use public cloud or private cloud to safeguard the privacy and sensitivity of data. And moreover, we need to strengthen the infrastructure for this home cloud healthcare in developing countries like India.
I think we lost Professor Ashutosh. Maybe Dr. Basin, you can take the question.
Yeah, so I think I fully understand, Dinesh, basically your point, basically like healthcare data breach and all that. So how about like what Dr. Khosla was saying, basically that like in days, the whole of education system become digital. Like it used to be like a classroom system, it become digital system basically. Because everyone because that is the necessity right now basically. So I think rural India, I think right now we have, I think at least telephone lines basically for getting, or you can say maybe like the mobile lines basically to get the data from those places. And I think if you look at some of the big companies like into the cloud business like Amazon or Microsoft, which are not HIPAA compliant basically. Most of the universities, like you look in US, right now all the healthcare data is like maintained at Amazon, Microsoft, which are HIPAA compliant, and they allow the transfer of the data in an encrypted format. So I think if we design a pipeline basically, maybe I will say like you need not to have a private cloud, use the available system basically, because otherwise it will delay the process further. So use a public system that is available, and they are pretty secured. And I think they are taking the step every day to make it more secure. And I will say, I think put the information on the system that is like more useful for helping the other scientists across the world or the healthcare systems as compared to like going into the private information of a patient. So I think that can be easily achieved today.
Basin, your audio is not there.
Okay.
Yeah, no.
Yeah, you're audible.
We could hear him, and Radhaji. I think it's your probably your.
Okay, sorry.
Yeah, so I think that I will say, I think Dinesh basically, because I think this is what I think we've been in the world basically like before COVID-19. Oh, education system need to have a special pipelines for doing the digital education. Now, as Dr. Khosla was saying, even my kindergartner, he go to school on like laptop. So like there is a privacy issue with that basically. All the things basically like, but I think we can use what we have right now. And I think public cloud system is like investing a lot of money to really attract this business basically. So I think like healthcare is going to be totally a digital transformation in coming years. Yeah.
I'll just like to add to here, Manoj, I think absolutely. So cloud is the future. I was speaking to a friend of mine who's actually building a business on telemedicine, and think about it this way: that you're wearing a wearable, and your data is being tracked pretty much 24 hours, 367 every moment of your life, and people can predict whether you're going to have a heart attack or you're going through any serious disease. That's connected to cloud, and people across the world can actually see your data. So that's one thing, Dinesh, that's going to happen. The second thing, which in my opinion, that's going to happen is something similar to online education, is telemedicine, which basically means, and I think it's already happening in a small way, which means I got a problem of health. I don't need to go to my doctor in Solon. I can actually send my reports to the best doctor in Mayo Clinic or Cleveland, or wherever, and he or she will look at my reports and give back results to me, get new diagnosis done. So the whole world of medicine is going to, the value chain is going to sort of, apart from of course surgeries which need to be done at a particular place, But who knows, there might be remote surgeries possible. You could be sitting in your hospital in Solon and someone in New York is doing a surgery because he's got the robot in his hand and he can sort of do the surgery sitting over there. So I think the next 10 years will be fundamentally different. And who knows, it could be robots, AI-driven surgery also happening. So expect major changes happening in the way at least medicine happens, education happens. I think it's going to be very, very phenomenal. And that's why I said all of us in this room today need to upgrade our skills, including me or Dr. Khosla, despite the fact that he's 80 years old. I would request him to also do some edX courses and upgrade his skills.
Thank you, sir. So with this,
yeah, I knew you were going to say that. So.
He's always ready for change, I think. So we have a really good leader for us. So to lead us with changes, with anything which comes up, we are ready there to lead. So thank you all. We end this panel session because we are running late already, and I think most of the participants might be impatient about the end of the session. So once again, I would like to thank all the expert speakers. I think Dr. Ashutosh Tiwari, who was talking about this cloud technology, he has possibly lost connection, or I don't see him now. So he gave a very wonderful talk on AI and the cloud technology. Then we had Dr. Bikash Medi. He gave us the real clinical aspect of COVID-19 and how can we have drug. And lastly, we had Dr. Manoj Basin. So he gave a complete overview of the COVID-19 aspects from epidemiology to vaccines. So with all this knowledge, we hope that we'll come with implications to the audience on how to tackle and what is the future, like what Atul sir said about the economic aspects. So the summary of the symposium would be a very big outcome for every audience here. And it will come out as a big deliberation for every one of us. So again, I would like to thank our Honorable Vice Chancellor and Pro Vice Chancellor. So you are the leaders who actually drove us and made this session happen. We're really grateful to you, sir, Professor Atul Khosla, sir. So you have been always inspiring us to do online aspects. Now you made it happen for us. So you're the guide there. So thank you once again. Now I hand over the session to Dr. Saurabh to end the valedictory session. Thank you all.
Thank you, Dr. Anuradha, and thank you all the panelists for a very, very informative and very, very nice talks and very informative day. So I'm not going to take much time. So it's a very, very small valedictory or closing session. So I'm going to present a small closing report for this 3-day symposium. So just for your information, that this whole 3-day symposium was conceptualized in a week's time. So a week back, we thought of having this online virtual 3-day international symposium. So it is being implemented on a week's time. So we started this symposium on 23rd of May, which is the inaugural day. On that day, Professor Khosla, our honorable VC, sir, he was the chief guest of the inaugural session. And he appreciated the efforts to organize this international symposium through Zoom or through online mode. He also emphasized that the coming time is the time of online education. And we all need to move towards the online world so that knowledge dissemination can be very, very fast, and we can connect to people across the world and can transfer the latest knowledge that we are doing through this webinar. The guest of honor for that day was Dr. Padma Shri, Dr. Dinesh Singh, who was former Vice Chancellor of Delhi University. He talked about redefining the libraries. So as the whole education system is being redefined, in the libraries also are redefining. We are not going to see those big libraries with a lot of physical books. Everything is going to be digital. So he emphasized a lot on redefining the libraries to a virtual world so that it can also transfer the knowledge beyond boundaries, so everyone and anyone can have access to that. The second talk for that day was from Dr. Naren Chirmule, who was ex-research head of Biocon. He very nicely articulated the immunological aspects associated with coronavirus infection. And he also talked about the current vaccine development scenario with respect to this coronavirus infection. with Dr. Naren Chirmule's talk, we ended the first day. The second day, we started with the talk of Dr. Yogesh Tiwari. He was a medical physician from M Hospital, Sweden. So he gave a medical aspect of the coronavirus pandemic, and he also emphasized that mobile-based healthcare systems and mobile-based healthcare devices is the future, and those are going to be very, very important in the coming time. The second talk was from Dr. Panesar from Slight Longowal. He talked about immunobooster foods, and he discussed about various foods from our day-to-day life and what are their immunoboosting properties, because now at COVID-19 times, everyone is concerned about their immunity. Everyone is talking how to boost immunity so that the chances of getting a coronavirus infection or chances of getting a acute coronavirus infection can be significantly lowered. Then Dr. Khanuja, who was ex-director of CSIR CMAP, he discussed the significance of medicinal plants and their phytoconstituents who are reported to have health benefits. He also talked about the food material from our day-to-day life, like millets and their health benefits over the other food items. So those two sessions on food and their phytoconstituents are very, very informative. So with Dr. Khanuja's talk, we ended the second day. Today, we have three eminent panelists with us. Dr. Ashutosh Tiwari from VBRI Sweden. He talked about nanosystems and devices for cloud care, which is the future of healthcare systems. We had a very, very good talk from him. And these are going to be extremely, extremely important for the countries like India, where the number of doctors over the population is significantly less, and there these cloud care systems are going to help the population in a big, big way. The second talk was from Dr. Bikash Mehdi from PGI Chandigarh. He talked about the drug development for COVID-19 and also talked about that how the present day drugs or antivirals are actually being used to treat coronavirus infection and the COVID management. Then the third talk was from Dr. Manoj Bhasin from Atlanta. So he talked about the genomics of SARS-CoV and also discussed about the current global scenario of COVID infection. So he nicely correlated different factors which are responsible for more COVID infection in different countries. He also talked about the genomic landscape of SARS-CoV and also discussed about the association of COVID-19 cases with various factors and what are the new drugs which are in the pipeline and vaccines in the pipeline. So all the three talks of the day are very, very informative. The fourth talk is from Professor Atul Khosla, our Honorable Pro Vice Chancellor, and he gave a insight on how the economics are going to change post-COVID pandemic. So a lot of things are going to change. The industries are going to change. He said that the tourism industry is going to be badly hit. Pharma industry is going to gain. And as we also see that there is a lot of shift which is happening from companies which are currently operating in China to India. But yeah, that's a big, big challenge that how Indian government means lay out the whole scenario where the companies can come in and can establish in India. He also talked about how education is going to change, which is extremely, extremely important. And we, as an academician, are also seeing that change, that online education is very, very important. And this whole 3-day workshop or symposium is an outcome of that. We have never thought of organizing an online symposium in a week's time. And it is because of technology, thanks to this technology, that people who are actually situated across the world, they are connected and they are now sharing the ideas online to the participants. I must say that for all the 3 days, so we have touched the number of participants around 300 means each and every day, means Saturday, Sunday, and Monday. So that's a very, very good sign that generally in a symposium, what happens is the strength goes down as the number of days progresses. But the people who are participating in this symposium on day 1, the same number continues to day 2 and day 3. And I can see the chat box, the response of the feedback of the participants. They are thoroughly enjoyed all the deliberations, and they are very, very excited that this kind of platform can also help in transferring information from the best scientists and best researchers to the participants. So before requesting Professor Khosla and Professor Atul for a brief concluding remarks, I would like to thank all the panelists who have delivered a talk during these 3 days of symposium. They have taken out time, so I'm very, very thankful to them for accepting our request and for delivering the talks to our participants and to all the faculty members. I would also like to thank our Vice Chancellor and Pro-Vice Chancellor, because it is their encouragement and their motivation that we are able to organize this in a short span of time. All of our reporters who are busy in compiling the reports. So the reporters for today is Dr. Nitika and Dr. Chandrika. So they are also there compiling the report of the day, and at the end, so maybe tomorrow or day after tomorrow, we'll come up with a brochure containing the reports of all the 3 days, and we'll circulate it to all the participants and to the panelists. So thanks to our reporters. I'm also thankful to all of our faculty members who helped and who participated in the workshop. And last but not least, all the participants who have taken out time. So I must tell you that the participants are from various parts of India, and we also have international audience who are actually listening the talks of the experts for last 3 days. So I request Professor Khosla first, and then Atul Khosla for a brief closing remarks, and then we'll close for the day. Professor Khosla, please.
My one line remark is, time is changing. We must learn to adjust with the changes. Thank you very much. We have to live happily in this life.
Atul, sir.
Thank you, Dr. Khosla. I think that was sweet and short. And there is something called, fatigue. So I've coined a new word called Zombie. So I am zombied after all my webinars and lectures that I give. So all of you are too, I'm sure. My only 2 last thoughts would be a great workshop. We should capture the learnings, which means let's have formal proceedings for this team, and let's have recommendations coming out of it, which we can circulate to the world. I think that will be valuable, and share it to everyone. So I wouldn't say more because I've seen the audience drop from 210 to 160. I think it's time to say bye-bye. So it's good night and be safe from my side, and over to you, Saurabh.
Okay, so thank you, Manoj, and thank you, Dr. Mehdi, for taking out time and for attending this symposium. Great talks. So thank you once again. I would also like to thank Dr. Anuradha, Dean of our faculty, for support and for all the encouragement. Dr. Dinesh, Head of School of Bioengineering and Food Technology. And thanks all the participants, all the faculty members, and thanks Shulni University. So we are done for this 3-day symposium, and I think this is a good and a great success. So all the success is because of the active participation of the panelists, our university management, and all the participants. So thank you, everyone. Good night. Stay safe. Stay home, and bye bye.
Thank you very much. Thank you.
Bye.